So welcome everyone to Halifax Center on Saturday, October the 3rd, a sunny day here in Halifax. Not sure what it's like across the country. We are addressing a whole bunch of topics today that I think most people will find of great interest. And just as an FYI, this session is being recorded. Just be aware of that. And within 24 to 48 hours, it will be posted on our RASC Halifax YouTube site. Our panelists today, although you won't be able to see them right now, are Dave Chapman, who'll be presenting the What's Up. Wayne Harasimovich, unfortunately was unable to attend today. Paul Heath will be doing a couple of segments for us, one being the Food for the Soul, and the other is the youth presentation. Blair MacDonald, and I'm sure everyone's been waiting with bated breath on this, will be announcing the winners of the Halifax Center AstroImaging contest. And we have a very special guest with us today, Lauchie Scott. A native son, by the way, although he has moved away, we'll forgive him for that. But I'm sure you will find his talk later this afternoon of great interest. If you want to ask questions during any of the presentations, there are a couple of ways to do that. There is a chat button at the bottom of your screen, as well as a Q&A. You can click either one of them. I will be keeping tally on that just to check when questions are coming in. So you can ask them that way. And please, if your microphone is not muted right now, can you please do so, because it picks up every sound that you have, that you're making in your background. And for guests who are joining us for the first time, we encourage you to join the Royal Astronomical Society of Canada. There are, I'll tell you how later, but what are the perks of joining? There are numerous. First of all the goodies that you get when you join. First one being the Observer's Handbook that every member gets annually. This is the latest. You also get a membership, or a subscription rather, to our Sky News. And if you listened in last month, you'll know that I really should have said Sky News Nova Scotia, because of all the Nova Scotian contributions to the latest edition. You also get a subscription to our scientific journal, Journal of the RASC. And most currently, you also get this, the Explore the Universe, guide, which is, it is actually a certificate program if you so choose to do so, but it does give you a background on all sorts of information about the skies and what you see up there. There's also a workbook associated with this that you can purchase online. So just be aware of that. You also have access to numerous RASC-sponsored presentations across the country. And the observing programs, such as the Explore the Universe that I just showed you. There's also Explore the Moon. There's a binocular as well as a telescope version. There's the Isabel Williamson Lunar Observe the Moon. There's Deep Sky Gems, all sorts of programs for the novice and experienced, and somewhere in the middle, observers to enjoy and partake in. From our perspective, from the Halifax Center, you get a subscription to our magazine, Nova Notes, as well as to access to our resources, such as our library, which, although it's closed for now, once we reopen, you'll certainly have access to it, and certainly our observatory, the St. Croix Observatory. And most importantly, above all of this, is the fact that you can access an incredible team of people, not only here, but across the country, who are willing to educate you, help you through any of the programs, answer your questions regarding astronomy. And that was the one thing that really drew me to the organization, not just the night sky, but the people that were involved. So keep that in mind. We'll talk later about how people can join. But before we get going with the actual program, I just want to wish happy birthday to everyone who has a birthday today and every day between now and our next meeting on November 7th. Congratulations on another year of circumnavigating the sun. Our first person up on our agenda this morning, I keep saying this morning, I apologize, is Paul Heath. Paul is a member of our board. He's been an outreach chair for many years, I would say, right, Paul? And he served as ex-president or former president of our center. He currently serves as a member of the Inclusivity and Diversity Committee at the national level. So on that note, Paul, I will let you do food for the soul. You have to unmute yourself though, Paul.
There we go. As most of you know, Food for Soul, I started as when I was president. I write poetry, and I decided to try writing poems about astronomy topics. So Food for the Soul evolved from writing poems about each of our astronomy meetings. Today I'm going to reprise one that I wrote for Nova East that a couple of years ago, where we focused on Mars. And I think it's appropriate again. Also, I was too busy to write a new one, but I hope you enjoy it. It's God of War, red eye rising. We stood in fear of your rising. With time in hand, we were shrouded by the color of your red eye rising. Yet with each fading, we claimed a victory over fear, until with polished sands, we found your life renewed. Red eye rising, again with fear we stood, to watch your watered paths extend in shrouded color of your red eye rising. Yet with each fading, we claimed a victory over fear, now sent our armored messengers to search the secrets of your hall. Red eye rising, we stand holding fear's embrace. As each door within your hall swings wide, you toss high again your colored shroud, a red eye rising. Yet with each fading, we've claimed a victory over fear. Now boldened by our pride, we stretch our hand to time and move to stand firm with your red eye rising. Hope you like that. That's directed at Mars. So get out and look. She's nice and high and very bright.
And last night she was in conjunction with the moon. Although we couldn't see it from our yard due to cloud, but I guess some of you did from the chat that's been going on. So good for you. I guess now is my presentation on news from the board. Slideshow. So, welcome everyone. It has been our custom to provide updates from our board so that people know what's going on, not only here at Halifax Center, but also when we have something exciting to share from the national office as well. If you have any questions regarding the center, the email address to reach me is there. It's president@halifax.rasc.ca. And if you're looking for more information about our center, just go to halifax.rasc.ca and you'll find us, and everything you ever wanted to know about Halifax Center would be there. As you can appreciate, given the set of circumstances right now, our members' meetings are held online through webinar series that are hosted through national webinar series setup. The board of directors meetings are held through our own account. You can see the dates that are there. And there's sometimes we have been trying to offer virtual observing and astroimaging processing sessions. And the next one, although we had to cancel it on the actual International Observe the Moon night, we have rescheduled it for the Friday, October the 23rd, with the rain date being the Saturday. And as with national office, one of the perks of being a national organization and being on Zoom presentations is that you're actually able to participate and listen to other centers' meetings, which we would not have had an opportunity. We couldn't travel to them all, but thanks to the internet, we're able to enjoy what the other centers have to offer to us. So a very positive note there. One of the members' meetings that I did not note a few moments ago was the members' meeting on requisition that is being held on Saturday, October the 24th. Everyone has been apprised either by mail or by email about this meeting. The purpose of the meeting is to clarify the proposal regarding the SCO electrification that had been sent out earlier in September. To answer the questions raised during the poll, there were 3 raised during the polling session, as well as questions to be received before and during the meeting, and to acquire members' approval of the plan and a method of financing the plan. If you have any questions that you really want us to answer, that you feel we might have to have some extra time to plan the answer for, please give them to us at the president at halifax.rasc.ca by the end of day Monday, October the 19th. That will give us the time to answer those questions. I really want to impress upon people the fact that this is sort of a once in a lifetime opportunity. Winston Churchill once said, everybody stumbles across a golden opportunity at least once in a lifetime. Unfortunately, most people just pick themselves up, dust themselves down, and walk away from it. This is an opportunity that the board feels we really can't walk away from. We really do want to take advantage of this at this time, but we're hoping that the members will agree with us when we have at the end of that meeting on October 24. Just as a matter of note, it's really great. Through the email system, our discussion list, we're finding out that people are still actually using SCO. A reminder that our policy regarding the use of SCO is still in effect, that no more than 10 people on site at any one time. But otherwise, please utilize the facility. It's there for everyone to enjoy. Something new in terms of one of our members has produced, Tony Schellink specifically, produced a video called International Observe the Moon Night, September 26/20, How to Observe the Moon. This was to be shown on the 26th. However, as you can appreciate, it was canceled due to lack of being able to see the moon. However, you haven't really missed it because it will be shown today. Congratulations to Stuart Cameron for completing the Explore the Universe certificate. Congratulations, Stuart. Stuart is a graduate of one of the courses that Tony Schellink gave through SCANS. And Stuart, although not a newbie to observing, he's had telescopes and whatnot in the past, but this time he did it with binoculars and included not only photographs at times, but also sketches. So congratulations, Stuart, on a job well done. Our board nominations, as you can appreciate with our AGM coming up in December, we do have to have nominations for our board. And just as a matter of note, our center does abide by the RASC policy regarding inclusivity and diversity and welcomes every member in good standing who's not less than 19 years of age to stand for election or appointment as an officer or director of the center. And any eligible of the center may be nominated as a director or officer at or before the AGM. So just to keep that in mind. So we are still looking for volunteers to person our board. Stepping down is Paul Gray as director and vice president for this coming year. Paul has been a very active member over several years, serving as president just prior to me and several other positions within the board itself. So thank you, Paul, for all those years of service. Tom Crosman has served as a director for the past 2 years. Charles White is the editor of the Nova Notes for the past 3. And Pat Kelly is stepping down in his role as National Council representative. So thank you all for giving of your time and your expertise. For re-election, the following people have offered up to be re-elected. I've offered up my position as president again. Peter Hurley has offered to be secretary, Greg Dill for treasurer, and 4 of the 6 directors, Matt Dyer, Paul Heath, Wayne Harasimovich, and Dave Hoskin, have agreed to reoffer as well, to reoffer for election. Pat Kelly, I mentioned he was stepping down as national director, or national council rep. He has agreed to stand for election as vice president, because that role had become vacant with Paul's stepping down. And also for reappointment is Mary Lou Whitehorn as honorary president. Dave Chapman has offered for an additional year as observing chair. Paul Heath as outreach chair, and Wayne has agreed as librarian. So what do we need? We need 2 directors at least. I say at least. There are 2 positions empty, but to make this a true election, there could be more than 2. Okay. The appointed positions, we truly do need an editor for our Nova Notes, and we do need a representative going to national council meetings. If you have any questions about any of those positions, the position descriptions are on our website, but you can certainly contact me at any time to discuss. And remember that nominations are welcome for all the positions, elected and appointed, and whether they're filled or not. So if you have an interest in any of these positions, please let it be known to us. The RASC calendars have arrived. Yay! Thanks to Paul and his team of volunteers, we have another incredible edition of the Observer's Calendar. Halifax Center has agreed that we will sell them to our members. How do you get one? Well, you send an e-transfer to Greg Dillard, treasurer, at treasurer@halifax.rasc.ca for $25. That includes the calendar and all shipping and handling. In the notes section of your e-transfer, please include your name, because your email address doesn't necessarily give us a clue as to what that is, and a mailing address to which you want the calendar sent. And why should you get a copy of this? Well, there are 3 members in our calendar this coming year. In April, you'll see Keith Egger in his photograph of the wrong picture. Yes, those 2 are reversed. My apologies. Keith is the one on the right, the red one, and that is the Tarantula Nebula. And in August, Jason Dane, his Prancing Horse Nebula and the Row of Fuci is on the left. And not to be outdone, our youth member, Fiona Morris, has her photo as well of the North American Nebula. So congratulations, all of you. And we can all look forward to seeing our fellow members in the calendar. So what's new at the national office? Well, the board has 2 openings available. It would be helpful if you had some understanding of what the governance of the centers are like, and have some idea of what it's like to be in a national organization or company, so that you have an understanding of how a national organization does function. If you are interested in this, please contact Pat Kelly. Note to our board members, if any of the directors are considering offering up to be a member of the board, you can't be an officer. In other words, the president, vice president, secretary, and treasurer cannot offer up for this particular role. The green laser pointer, that is an ongoing item at the national level. Transport Canada did extend the certificate for another year. However, in reviewing the materials that they had produced, I raised concerns regarding the training process and branding, etc. So they're going to be looking at this and reviewing what's been going on there. So that is still open for their review. Center Operations Manual, it's almost done. Pat assures us that there's just a few holes that have to be filled in, and then that will be available. It's basically available as a backgrounder and a reference manual for all the centers, especially those that don't have a current set of bylaws and policy manuals, unlike our center, which does have those. The Education and Public Outreach Committee is actually meeting tomorrow afternoon, inviting guests to talk about could centers share material and resources, And could centers share meeting presentations? That should be a very interesting discussion because I think everyone can agree that we should be doing both, especially when we have that ability with the Zoom and internet capability. There's about to be a 30th center joining our group, the Fraser Valley Astronomers Society. It just has to be approved by the board. It's a small group, so hopefully they will be approved to go. National committee changes. The fundraising committee has been disbanded. Their mandate has been completed, and any roles that have to be completed regarding fundraising are being done by national staff. The publications committee is now an editorial board, and something new is the next generation committee, and Keegan Oikel is our youth member that is a member of that particular committee. So thank you, Keegan. And the nominating committee is now the whole board. And there is going to be one change to the policy manual regarding policy G23, which relates to complaints and mediation. There are going to be some changes to the process that we're going to be looking at in the coming year. So I mentioned earlier about all the perks of joining. Well, but I didn't tell you how to join. Well, now I am. There are two ways that you can join RASC. First, you can join online on our site at halifax.rasc.ca. On becoming a member, you can join the center if you click on join, that will get you to the national website and the form that you have to complete. Just be sure that you note that you want to be affiliated with Halifax Center. So that can be done online, including payment. Or if you're old school and prefer to mail in, you can click on form and that will give you the PDF of the form that you can then complete and mail into RASC with your payment. And yes, and one of the other perks that I failed to mention at the beginning was the discussion list. There are two discussion lists that you can also join. One is the National RASC discussion list as well as the Halifax Center discussion list. So what's going on this month? Well, first of all, our special guest, Lauchie Scott, is going to give us a presentation about a snapshot of the DRDC Space Situational Awareness Research and Development. I'll let him explain that a bit more. We have our members meetings today, and then we have that members meeting on requisition on the 24th. The board of directors will be meeting on the 29th. There are 3 sessions of Explore the Universe, and please note that the session on the 29th is the last in the series that Jenna Hines and John Reed will be conducting for that particular program, although you certainly will be able to access it on video through the national site. And as well, there are 2 more episodes of The Insider's Guide to the Galaxy. So next month, we have the usual up for grabs in terms of a photo montage with Paul Ray, What's Up with Paul Heath, Dave Chapman, and Food for the Soul with Paul Heath. I'll give the news from the board, and then we'll have a video presentation on the Litchfield discussions, which you'll hear more about later. And our members meeting is November the 7th, along with 2 more episodes of The Insider's Guide to the Universe, to the Galaxy. So, any questions? Okay. Given there are no questions, the next thing up is, I'm going to switch things around. I'm going to have Dave Chapman do his What's Up, if he would. Now, Dave Chapman is our observing chair for this particular year and will be in the coming. Dave has been serving numerous roles, both here in the center as well as nationally. And I will let him take it from here. Our lunar expert, Dave Chapman.
Hello, everyone. Are you letting me have the screen?
I thought so. Second here now. Yeah, It should.
Okay, I see you. I see you. Okay, can people see me?
I can see you.
Okay, good. All right. I'm still getting used to Zoom. All I can see is you. Anyway, welcome everyone. Thank you for having me back to do What's Up. I just wanted to mention, Judy did a great job explaining everything. On your calendar, you did leave off the 23rd of October. Is it 23rd or 24th? We're doing the Explore the Moon live broadcast. Wasn't on your calendar for next month or this month. That's this month. Yeah. Okay. Anyway, before I get started, I want to do a plug for, again, for Darkest KG beer. Can you, oh boy, oh boy. Darkest KG beer that's fading in and out. I better get rid of my background, I think, to do this.
Just don't hold it so close to your screen or your camera, Dave. Hold it
It's
back
better
where
just
you're at.
not to have it. It's just better not to have it. Anyway, I'm going to do a plug here for Darkest KG beer. This was brought up by Boxing Rock in Shelburne, Nova Scotia a few years ago to sell beer, obviously, but also promote Kejimkujik Dark Sky Preserve. A portion of every case goes to the Friends of KG Association. It has this cool box, and we gave them permission to put the Dark Sky Preserve logo on it and a little explanation here about Dark Sky Preserve. So RASC endorsed this. And currently it's back in production. It was off for a while. It's in production for the next few months. It should be available until December. And every box comes with a collectible constellation card designed by yours truly. So there's 6 of these. I got a complimentary copy. I don't drink that much beer, so I got them to give me a complimentary copy. I've got all 6. And if you collect all 6, you can enter for a supposedly fabulous prize. So I don't know what that is. They haven't asked me. So let's do What's Up. I'm going to share my screen. Okie dokie. So you see my title slide? Yes?
Yep, no problem, Dave.
Okay, thanks. I need confirmation because I don't know.
We'll tell you when you go wrong.
Oh, well, you could just do that continually, can't you? Okay, so What's Up is a presentation I prepare every month, and I present it at the meeting, but also at the beginning of every month, on the 1st of every month, it's posted to our website. So if like today, well, most months, the meeting isn't at the 1st of the month. So if you're interested in what's going on at the beginning of the month, you can go to the website and see what's there. So next month, it'll be up on November the 1st, even though our meeting isn't going to be until, I guess, the 6th or something. Anyway, so I do that with the help of the Observer's Handbook and Sky Safari. So I'm going to tell you what's going to happen this month, October. That picture, that background picture there is a portion of a picture I took back in August, where I was trying to see how early I could observe the star Sirius, which is a winter star. And that was August the 21st. I was able to see Sirius rise before the sun, and I was able to pick up this picture of the winter hexagon and the winter triangle. So that was a fun little project to do. So what's going on with the sun? So October is an interesting month. If you just look at the daytime and the nighttime and ignore the twilight part, at the beginning of the month, we have more day than night, and at the end of the month, we have more night than day in terms of actual night and actual day. So the sun's setting quite early now, and it gets dark, so you don't have to wait up till wee hours to observe. Number of hours of darkness is increasing. I must have made a mistake there on October 31st. I didn't update that. The number of hours has got to be bigger than that. And you can see the sun is getting lower and lower in the sky. By the end of the month, the sunlight is only 10 hours long, which means that it's pretty much the end of the gardening season here. Like there's not many plants will grow with less than 10 hours of sunlight. So I've still got tomatoes on the vine. So as a gardener, I'm quite pleased with what's going on right now. And you can see there's little pie charts that I make every month so that you can get a pictorial image of what's going on. And if you follow that, if you go online and follow that link to the YouTube channel, you will see an animated view of that. At the top right, I'm not going to go to today's solar activity, but again, if you go to the web page and click on the PDF link, it will take you to the page which tells you all about the sun and all kinds of different wavelengths. We are in solar cycle 25, but only just. There's not a lot of sunspots on the sun just yet. So here's the first quiz question. Anyone, what happens on the night of October 31st, 2020? Anyone? Hello?
Trick or treat.
You're right. That's pretty obvious, but something else happens. Anyone? Is anybody?
Moon, isn't it?
It is a full moon. Yes, it's the second full moon of this month, in fact. But there's one more thing that happens that night, and I almost missed it. Is anybody on the chat saying anything? Okay, I'm going to tell you.
Time change?
What? Yes. Because we changed the time on the first Sunday in November, it's rare that, well, not super rare, but the 1st of November is a Sunday. And so on the night of October 31st, we have to change the clocks. So after all the trick-or-treaters are gone, and when you go to bed, you have to remember in the morning to change your clocks. So we're springing back.
But that's thanks to Fabian Pittman for that answer, Dave.
Okay. Yeah, well, I almost missed it. I almost missed it because I thought it always happened later in November, but this is one of the rare occasions. Well, it's not that rare, but it is rare to have a full moon on Halloween. It only happens about every 19 years. So that is a rare thing. And that doesn't take very long to figure out if you know your moon theory. So anyhow, it's going to be an interesting night all around. Okay. So speaking of the moon, well, yesterday was the full moon, October 1st. It was the mate calling time, so it's the mate calling moon. And last night, the October 2nd and the 3rd, there was a conjunction of moon and Mars, which most of us here missed because it was cloudy, although I see other people took pictures of it. Coming up on the 4th, and this will be a morning thing, the moon and Uranus will be close together in the sky. So if you would like to look for Uranus, get up before dawn, before dawn breaks on the 4th, which is what, tomorrow? Yeah, tomorrow. Get up early, or get up really early, observe Mars, and then look for the moon and Uranus. Because they'll be in the same binocular field. October 10th is the last quarter, which is again a morning thing. The new moon is on October 16th, and it's the same day as perigee. So here in Nova Scotia and any place along the coast, you'll see large tides. And that will be the new cycle of the animal fattening time, Wikewigus, and I'm gonna try to play this. Oh boy, this is where I always get into trouble. I wish Zoom was better with this stuff. I can't see my desktop. Well, maybe I can. Oh, well. You know what? I'm not going to play it. Can you see my moon thing again? My moon thing here?
The moon this month?
Yes.
Yep.
Okay, thank you. Anyhow, if you go to the online version of this and click that link, you will hear Curtis Michael teaching you how to say Wegewi Goose. Well, I just did, but he does a better job than me. And speaking of Mi'kmaq moons, we did just a few weeks ago, we did a webinar with the RASC London Centre that I think went very well. And if you go to our YouTube channel, you'll see Kathy and I giving that webinar. We both thought it went well. So if you haven't seen us present that, I invite you to go and have a look. And it's about an hour long. Okay, I'm changing things around here. Every month I put up the moon and explore the universe, the list of everything, but I don't know how much it gets people out to observe. So this time what I'm doing is I'm gonna say, if you go out on the first quarter, which is actually the weekend we're gonna do the Explore the Moon activity, these circled items are the craters and mare, which will be best on view around that time. So the challenge is to go out and observe those items. So there's 1, 2, 3, 4 mare. I mean, you can see more than that, but I'm only asking you to look for those 4. And there's 4 craters that are in Explore the Universe. So if you're working on your Explore the Universe program, that'd be a good time to observe the moon. It's high up in the sky. At sunset, you can grab binoculars. You shouldn't have too much trouble finding it, even if you're challenged with trees and buildings around. Okay, the planets this month, well, Mercury is just too close to the horizon and the sun to see. It's not good to see. If you were in the southern hemisphere, it would be a good apparition, but not for us. Venus is still high, and it's quite brilliant in the eastern morning sky, easy to pick out, and it's embedded in the morning zodiacal light following October 13th. That's when essentially the moon in the morning, the moon will be out of the sky, so the only light pollution will be Venus. So, and yeah, this morning, I think people saw Regulus and Venus together. It might still be viewable tomorrow, kind of a conjunction between Venus and Regulus. Mars, oh boy, this is the time for Mars. This is what you should be doing the next little while, the next month. You should be focusing on Mars. It's going to get to magnitude -2.5. It'll be brighter than Jupiter. The disk size doesn't change all that much because it's passing by us, so it's not changing its distance very much. But it increases a little bit over the month. But it's a good size to look at in most telescopes. The closest approach is coming up on Tuesday, and the opposition is on the 13th. Now, you might wonder, why are not those the same things? And if Earth and Mars had circular orbits, they would be the same. But because both Earth and mostly Mars has an elliptical orbit, fairly eccentric, the closest approach and the opposition doesn't occur on the same date. So the closest approach is the date when it's closest. So that's when you should be looking. And the significance of opposition is that after October the 13th, technically it's in the evening sky rather than in the morning sky, which it is now. So I had to wait until 11 o'clock the other night to see it rise over my house. Maybe if you're not so challenged in the southeast, you could probably observe it a bit earlier, but don't observe it when it's too low in the sky because it'll be too wavy. So the challenge here is whatever telescope you have, just go out and try to observe the South Polar Cap there's quite a lot of contrast between the polar cap and everything else. So even if it just looks like a little white dot, you might be able to see it even in a small telescope. For extra bonus marks, you can see if you can make out dark markings on the surface, that it's not just a red blob. Just give it a go. It's worth trying, because it won't be another 50, it'll be 15 years before we have a close approach like this. And that's easy to observe. And so it's worth you trying sometime this month. Jupiter and Saturn are still in the southwestern sky. They're in the twilight. On the 22nd and 23rd, they're close to the moon. And they're heading towards a close conjunction on December the 21st. So anyway, I always, when I get my telescope out in the evening, get it all tuned up and collimated, and I have a little look at Jupiter and Saturn. Then I put my telescope to sleep, and then I go have a nap, and then I get up later to look at Mars. Neptune is in the evening sky. You could pick that out with binoculars if you tried. It's just past opposition. And Uranus and the moon on October 31st are close to one another. Well, that's the same night, the Halloween night. So if you want to find Uranus, look on Halloween night. You'll be able to see it in the field of view, and Uranus will be at opposition. So that's what's going on with planets. I do want to say, I'm going to do another plug for Mars here. This is typically what Jupiter and Saturn looks like, and this is what Mars will look like on the 6th. So it's kind of in between the disk of Saturn and Jupiter. So if you can imagine looking at Jupiter in your telescope, then Mars is a little bit smaller, and should have a look. If you want any tips, read the Observer's Handbook. Marie Paulson has quite a nice essay on Mars, and he has a lot of tips on observing Mars, including the use of filters and that sort of thing. So I just say, push whatever you have, push it to the max. Can you see the south polar cap? Can you see any markings? Most of the telescopes are probably optically up to the task. The trick is your mount has to be steady, because when you're pushing things to the highest magnification, any vibration or uncertainty in the pointing of the telescope is going to be a frustration. So it's really a test of your mount more than anything else. I included my latest sketch of Mars there. It's the best view that I've had just the other night. I'm quite pleased with that. David Hoskin took a picture, and it compares favorably with that when you move it around and look at it. And there's Ian Wheelband, who's actually from the Toronto Centre, but is living here part of the year. He also imaged Mars. And so I don't know if Paul Gray is going to show some pictures later. I hope so. So here's the view of Moon and Jupiter on October the 22nd. It won't be hard to find Jupiter, but it is in the field of view. And I did mention that the Moon and Uranus are close by on October the 6th, which is, if you stay up, or if you're up looking at Mars the evening before, you should, it's not, the moon's not going to move that quick, so you should be able to pick out Uranus. It's pretty easy with your binoculars. The other thing that I wanted to point out is the Orionid meteor shower on the night of October 20 into 21. The observed rate is not that high, but they're fast meteors and they often leave trains. So it's worth, if it's clear that night, it's worth having a look, because the moon sets pretty early, and the radiant is above the horizon at 11. The peak is the morning of the 21st, and dawn comes at 6. So there's actually an opportunity there, if you don't mind staying up. what day of the week is that? Unfortunately, it's a Tuesday, Wednesday. But if you have some kind of a dark sky, you might even be able to pick some up in the city. And the reason it's important is because the parent comet is Comet Halley. So if you're one of those people who are in between apparitions of the comet, if you want to see a piece of the comet, go look for an Orionid meteor. Okay? Anyway, it's just an opportunity there for solar system observing. Okay, let's talk about Explore the Universe. I'm doing the autumn constellations, autumn things this month. So they're on the screen there. So Pegasus, Andromeda, Cassiopeia, and Perseus are all key constellations in the legend of Perseus and Andromeda. I do have a thumbnail version of that story. Basically, Cassiopeia brags about her daughter being the most beautiful, even more beautiful than the sea nymphs. They understandably get upset and complain to their father, Poseidon, who unleashes a monster, Cetus, to ravage the coastline. And King Cepheus goes to an oracle and is told that he has to sacrifice Andromeda to stop the carnage. And so he does so. Poor Andromeda. I mean, come on, it wasn't her fault. And just in the nick of time, Perseus comes along and kills the sea monster with the head of Medusa, which turns the sea monster to stone. And they live happily ever after. That's it. That's the short version. Aries is there. I don't know why they included Aries in the autumn constellations. It's a pretty small one. I would have put Cepheus or Cetus in there, but anyway. So those are the constellations, pretty easy to see even now. Don't have to wait up too late to pick those out. As far as stars are concerned, there aren't any super bright stars in the fall sky, but they're easy enough to find. The brightest one is Myrfak, which is Alpha Persei, and it is the 35th brightest star in the night sky. It's also a navigation star. And then in order of brightness, we've got Hamal, Alpheratz, Algol, Shedar. Shedar is in Cassiopeia, it's Alpha Cassiopeia. Alpheratz is Alpha Andromeda. Interesting trivia, it's part of the square of Pegasus, even though the star technically belongs to Andromeda. So that's kind of a little trivia quiz thing. Algol is the famous eclipsing binary star. Markab is the brightest star in Perseus, I think. Yes, must be. And I have no idea why they put two stars in from Aries, Hamal and Sheraton, as stars for Explore the Universe, because there's some other cool stars that you could have chosen. Anyway, all the ones marked with N are official navigation stars if you navigate with a sextant. And all of the stars listed here, if you have a SynScan, a Skywatcher SynScan go-to telescope, all of those stars are you can use to align your scope to the sky. So it's good to learn where they are. Because when you use your hand controller, it just has the name. So you got to know, you got to know where they are in the sky in order to use them. So I made a little chart to help me. As far as deep sky objects are, it's pretty slim pickings for Explore the Universe, and that's because you know, fall is like there's a lot of well, you know, they could have put more in. But there's only three anyway. There's the Andromeda Galaxy, which is, you can even see that from the city with binoculars. The double cluster, which is between Cassiopeia and Perseus, and Melot 20, which is also known as the Alpha Persei Association. So if you look at Myrfak, the brightest star in Perseus, with binoculars, you'll see a very broad cluster of stars. Maybe Pat Kelly could look it up. The reason it's so broad is probably because it's pretty close. Maybe he could check that while I'm talking. But it's a really nice binocular, wide field thing. It's not a telescope thing at all. So the challenge is to pick those out, the double cluster, and then the lot 20 in the Milky Way. They're coming down from Cassiopeia into Perseus. As far as double stars, this is another thing that I don't understand, but they only have 3 double stars for the autumn and winter months in Explore the Universe. And one of those is in Cygnus, which you could argue is a summer constellation. Anyhow, it is what it is. So we've got 16 Cygni, which is a nice pair of almost equal stars, fairly broad. So these are all, again, binocular objects. Delta Cephei, you should be able to see those in a good pair of binoculars. You might need to steady them to see 41 seconds of arc. Delta Cephei, of course, is, it's funny, it doesn't have a name, a proper name, but it's also known to be, it's a very important variable star for measuring the size of the universe. Don't have time to talk about that, but Delta Cephei is a very classic variable star. So I guess the challenge is, yeah, go look for Delta Cephei. It's pretty high up in the sky most of the night, and with tripod mounted or steadied binoculars. Actually, you could try lying on a lounge chair or something and holding your binoculars up and see if you can see that double. So those are your Explore the Universe for the autumn. And I'm finished my presentation if there's any questions.
Pat said, Dave, you are correct. It is only 172 parsecs away.
What's that in nautical miles? I can't remember what a parsec is. It's about, what, 6 light years or something?
It's 3 point something.
Oh, okay, so it's like about 1,100 or something, 1,000 light years away, which is relatively close. And Paul said something here about the Draconids may be seen. That's right. There was kind of an outburst of the Draconids a couple of years ago. Is that expected again, Paul?
October 7th, there might be a possible outburst again.
Oh yeah.
They're not giving any numbers. They're just saying that we're going to have a close path to 2 previous paths of the comet, the path from 1704 and the path from 1711. So they're going to be October 7th at 1:25 UT and October 7th at 1:57 UT. So both of those will be
so those are the late
hour time.
Here.
Yeah. And Draco, it's near the head of Draco, so it's way up about 70 degrees high, about 9 o'clock, 10 o'clock in the evening for us.
So if
it's well placed, it's an evening thing you can do. The moon doesn't rise so early.
If it's clear and people are out looking at Mars, they might see some meteors, eh?
Yeah, and they're not very long meteors. They're very short. So you really kind of have to be looking towards the radiant for this one, almost directly up overhead. And they're very slow, so they're very, very easy to determine at the Draconids compared to a lot of the other meteors. They're extremely slow. I know the other year when I walked out to see them, just by chance taking the dog out, saw 1 or 2 quite quickly, and I was like, those are definitely Draconids because of the radiant and the speed. So you never know. It might be something, might not be.
I see a comment here from our esteemed honorary president about the Alpha Persei. I think she's talking about Alpha Persei. She says she believes it's bright because it's an OB association. OB, so they're fairly hot stars, I guess, O and B. Is that right? Okay. All right.
Good. Well, thank you, Dave.
You're welcome.
I'm sure giving people lots of things to go look for this month. And
well, there is quite a bit to look for. The only thing we have to cross our fingers for is if the weather will cooperate. That's always the bugger, you know. But there's enough things to look for that hopefully we'll be able to see some of them. And that's where the moon comes in handy, because, you know, you should be able to get a clear night every 3 days or so at least. So there's always the moon, right? You don't pack up your telescope and put it away because the moon's out. You observe the moon. That's what you do. And especially if you're in the city, there's not much you can do with deep sky and that. So my motto is you observe what you can. There's always something to look at, right? Somebody asked me when I slept, and I said, you know, astronomers, they observe when they have to, and they sleep when they can. That was my answer.
Okay, thank you. And speaking of looking up in the sky, one of the things that I failed to bring into the agenda earlier on, but it seems like a perfect spot to put it today, is the photo montage. Paul Gray every month puts together a montage of the photos that members have put up on our discussion list and other sources, and shares with us so we can all see what's been up on the discussion list. So Paul, I'll let you take it away, please.
Alrighty. Thank you, Judy. I try to do it every month, but it's actually been since May that I have done one. So we actually have a fairly large slideshow, 76, I believe I have in here. And I'm going to just let it run. It's going to be about 5 or 7 seconds per image, I think. Kick this into gear. It should go automatic. And it is pretty much images and sketches that were sent to the mailing list. So not from the Facebook page or any of the other places or from people's websites. This is purely what was sent onto the mailing list. It's just easier for me to track and keep a database of who's is where and when. And then I just go through and put everything together sequentially from the year. So it's all in chronological order as things were observed. And since May, we've had an amazing year. We've actually had quite some amazing stuff to look at and some great observations and some good weather. And you'll see that throughout this montage. Both photos that people took. May, we had some great skies. We had, of course, no airplanes. We had blue sky, some transparent air, some nice dry Arctic air, and it made for some great imaging during the dark moons of May and June. A few of us got out and got some really good photos for deep sky. And then after that, of course, we got into the comet, we got into Mars, there was a conjunction thrown in there somewhere, and that's all shown in the slideshow this month. So there's quite a bit of stuff that was done. And this is a testament to how good those skies were. Bernard's Snake Nebula, this is way down in Scorpius, and to be able to get that kind of stuff in the southern Milky Way near the horizon from North America is really amazing. So we've had an amazing run of weather. I know it hasn't seemed like it at times, but really it's been great. Mike Boschat's been doing amazing stuff. What's really neat here, right here is the moon. You just see the thin fingernail of the moon down in the bottom. There it is again. Dave Chapman got it as well with the conjunction. It's amazing that these guys, Dave, Michael, grabbing the moon, such a thin moon. Melody sketches. Of course, I made this a lot quicker of a display this month because there is just so many slides. Roy Bishop, this I believe was from his backyard, or his front yard actually, looking west across the fields. Bruce Hamilton down in Litchfield. Jerry Black, Venus, Mercury, and of course Moon. I'll point out the ones that are a little hard to see. It's a gorgeous shot, David, too, with the moon, the earth shine on the moon.
That was taken with my iPhone.
Yeah, it's amazing, eh? Now you're hooked.
Not quite.
Jerry, hide the refractor.
And there's even a sunspot. There's one back in, I believe this was June when Dave Hoskin took this one. I think Mike Boschow has one here recently as well. A couple nice shots from St. Croix by John McPhee.
Mm.
Notice the red lights on the horizon. That's all the windmills that they added to our east. Yes. Now, Dave Chapman and Mike Gatto, I'm not sure. My notes weren't good. I don't know who took this photo of the next one, but I know it was one of the two of you. So I wasn't sure who to credit it to. But there's the moon and Venus first, early one morning. And then the comet came.
Those were mine.
Those were yours, David? In early July, the comet showed up. And I think there's about 30 shots of the comet in here over a 3-week period. These shots are all early morning near this part of July, back in early July. These are 3 a.m., 4 a.m., I believe. Is that still in the morning, David?
Yes, I can tell by the background.
Okay.
One thing I'm noticing is you don't see the iron tail until a little bit later in this.
Yeah. That was actually an evening shot. So the 18th was when it started coming around the evening. 17th, 18th is when I first started seeing it in the evening from the valley. Mike Gatto was at Five Islands Provincial Park for a couple nights. Got all the satellites. I had four or five satellites in that one shot. And finally on its way out, I think Bruce was one of the last ones to take a picture of it as it faded away.
And these are Michael's sketches, correct?
Yep, these are Mike Gatto's sketches. They're always amazing. The prominence on the sun there, that's just this big group. Excuse me. More Mike Gatto sketching. There's a lot of Mars sketches here between Mike Gatto and Dave Chapman. It just goes to show what can be seen if you take your time and go out late at night after midnight and really take your time and look at Mars for a period of time and train your eye to see. I like this sketch of Mars by Mike Gatto. I was actually imaging at the same time he was sketching it. So there's my image matching his sketch.
I think we should put out a map of Mars.
I think Michael should put out a map of Mars. He's doing an amazing job. You can't get over some of the detail he gets. You don't have to be an artist. Even Mike Boschert says you just have to sketch what you see. That's a real nice one too, David.
That was the best view of Mars I've ever had in my life. It was just, you know.
That's that. So yeah, tons of work happening. Some great stuff. I mean, great conjunction, the occultation of Venus. We had the comet. We have Mars going on. So it's been a great summer for observing, really.
It has. We were blessed with an incredible summer here this year, which is not like us, but we'll take what we can get. Okay. The next item up to follow this is our AstroImaging contest. This is a contest that for many years was held as part of Nova East, and then 2 years ago it became a photo contest for our center itself. So it's the Halifax Center AstroImaging contest. It in essence mirrors what they do at National in terms of there are 3 categories: the solar system, wide field, and deep sky. Except the submissions have to be from members within our center or a resident of Nova Scotia. We have limited it to that. Blair MacDonald will be up in a moment to provide the winners of those 3 categories, as well as the People's Choice Award, which members of our center were polled to vote for those particular sets of photos, 34 actually, that were entered this year into the contest. We also need to really thank Atlantic Photo Supply for contributing to this in terms of the prizes for the winners of the 3 categories. First place of the 3 will receive a reprint of their photo in a wrapped canvas format. It's $150 plus value, so it's be an incredible opportunity for these folk to get their photos reprinted in that way. So thank you very much to Atlantic Photo for their assistance in this and for offering up those services. So on that note, I will hand it over to Blair. Blair is a longtime member of our center. He's also been a member of our board in various capacities, and he currently serves on the RASC Imaging Committee. So Blair, I will let you make the formal announcement of the winners of our contest for 2020.
I'm going to make people wait while I do that too. So let's see, I should be able to share my screen here. Bear with me a minute. Let's see if everything works. If I blow that up full screen and then do this, can everyone see the 2020 AstroImaging contest title slide?
Yes.
Yes.
Okay, so hopefully this works. Hopefully when I click on this, it begins to move here. So as Judy said, this contest started several years ago as a Nova East contest, and it has grown. Our sponsor is, of course, Atlantic Photo Supply. And I just want to make one comment about the canvas print version that the winners will have the opportunity to get. Canvas print is just about the ideal way to display astrophotos because all the imperfections disappear in the canvas weave. It makes for a really nice astrophoto to put up on the wall. So at any rate, let's get started here. First off, congratulations to all the entrants. We had a record number of entrants this year to the point where it kept the judges very busy. We've had 2 or 3 and 4 and 5. I think last year we had something like 9 entrants. This year we had 18 deep sky images, 5 lunar or solar images, solar system images, I should say, and 11 wide field images. And with so many great images, it was really hard to pick winners. Even after averaging the input from all of the judges, basically first and second in most of the categories are separated by fractions of a point. I think the biggest spread was between first and third, and it was a whole 3 points. So as you can see, we had some great images come in this year. So let's just take a quick look at some of these images. We've got an awesome shot of the half of the Veil Nebula, the Heart Nebula, another rendition of the Heart, the Iris Nebula down here. This is the Eagle Nebula, although it's a little hard to catch in there at this scale. The Orion Nebula, a section of the Andromeda Galaxy, and this one in particular I quite like because take a look down here, you can actually resolve some of the dust lanes and dark areas in one of the companion galaxies. It's actually a well done shot. Whoops, let's try that again. There we go. We've got a shot of M81 and 82, a very nice globular shot. And I think this one was Jeff's, I'm not sure. And a great shot of the Cygnus Wall, the Eagle coming in for a landing, so to speak. This particular shot, if I remember correctly, is Kathy's, and great shot of the Crescent Nebula. Here we've got a shot of the Bubble Nebula. Another shot, a little wider field of the Cygnus Wall area of the North American Nebula. The Pac-Man Nebula, and although it gets a little lost in a bit of a gradient, you can actually see some great detail in the nebula itself. A wider field shot of the Andromeda Galaxy, an M33. And this is a great shot of the Tarantula Nebula. It's one of the more interesting shots we've had come in, mostly because, of course, it's a shot of an area that most of us don't get to see. You have to go a little further south, like below the equator. They get all the nice targets. And we had some great lunar and solar system shots. So here we've got a great shot, nice close-up of some lunar detail. Again, great lunar detail here. This is a shot of the moon, and if I remember correctly, that is Venus right there, just before things disappeared behind the moon. The moon in color, and I'd like to point out to those that aren't familiar with doing this sort of an image of the moon, the colors here are actually real. Those are not false color. You have to do a little bit of processing to bring that color out in a moon shot. But if anyone goes and takes a look on some of the Wikipedia sites about color on the moon, the blue color is titanium deposits on the moon. And it's actually real color that you can see with virtually any color camera, as long as you're willing to do a little processing to bring it Here we have the moon and Mars at a close approach. And some of those comet shots that Paul had whiz by on his section there with all of the images from the last 3 months, Paul. But at any rate, some great shots of Comet NEOSSat, the moon coming up here. And then some of the wide field images, which just blew me away. We've got a great shot of the Milky Way at Peggy's Cove, another comet shot wide field with some interesting foreground, and Orion rising up over a very darkened background, some trees in the background there. Great shot of the Rho-Fucus here, the prancing horse. We've got M8. I think that's M20 up there. So just some fantastic shots that have come in. This shot actually Dave showed earlier in his What's Up presentation. Here we have a shot of the Milky Way rising over, I think that's Bayswater, if I remember correctly. And just to give people an idea of how these images were judged, we've had 3 judges rank the images. The results were averaged for a final score. The images were judged in a variety of ways, similar to, as Judy had mentioned, the RASC Astrophoto Awards that any member can apply for. We have, as we said before, several categories. The deep sky and lunar planetary imaging is a little more technical. The wide field has a big artistic impression component, mostly because we've got some very nice foreground elements in most of those images. And the winners are, so for lunar solar system category, we have Dave Hoskins' excellent close-up image of the moon, Aristotle, excuse me, Aristoteles, and I can never pronounce that, Exodus?
Eudoxus.
What's that?
Eudoxus.
Eudoxus, there we go. As he calls it, the bike wheel lunar craters, just a stunning shot. Great noise control, nicely detailed, very sharp, and he put a lot of work into that using lucky imaging. And he's the lucky recipient of first place in the lunar solar system category. Next up is a wonderful wide field shot by Jason Dane. And it was over Bayswater. Look at that. The Milky Way shot. It's just one that several of the judges really liked. The composition is wonderful. He's got just the right amount of lighting in the foreground. It turned out really well. And for the deep sky category, this one was a really hard category. I've personally flip-flopped between several of the images multiple times. This is a Heart Nebula mosaic that Jeff Donaldson had been working on for the last little while. It's actually 4 frames off his CCD camera, and he did a great job on capturing it, processing it, and putting it all together. He managed to keep a fair amount of star color. He didn't clip the background, so you can see all the gas and dust and the dark areas going well away from the nebula that show up all the way out here. Just a great shot. So at any rate, that'll give people an idea of the level of talent that several club members have in putting some of these together. We've just got some excellent astro imagers here in the club. And of course, the People's Choice Award goes to Jerry Black for his Comet NEOSSat shot. Judy, I know Jerry's there. Where was that shot taken? Was that at?
That was Site 15 at Kejimkujik National Park.
There we go. Again, another great shot, and that'll look great on the wall. And Judy will even let you put this one on the wall, I'm sure, Jerry.
I'm sure.
She's just not saying what wall. At any rate, that concludes the astrophoto competition presentation. And again, I just want to congratulate all of the people that entered. We had some great shots, and the judging was very difficult this time around, and keep them coming for next year.
Thanks so much, Blair.
You're welcome.
Just a note to the winners, Atlantic Photo Supply will be emailing the winners to advise them as to how to get their photos reprinted with them. And a gift certificate was given in a private ceremony to the People's Choice winner. So he's already received his prize ahead of schedule, but the others will be advised either later today. I will be emailing Atlantic Photo to apprise them as to who the winners are, and they will be hearing from Alan Sutherland shortly thereafter. So congratulations, everyone. Job well done. Incredible photos, and I can see why the panelists had such a challenge in determining the winners. So thanks for your work.
I have a question for Blair, if I can.
Yeah, go ahead, Dave.
Can you tell us how many of the entrants were not members of the RASC Halifax Center?
Not offhand. I don't have the list in front of me. Most of them were, however.
Okay, that's fine.
There may have been one or two out of the 34. In any case, I had promised a video from Tony Schellink that he had developed regarding the International Observe the Moon. And that's going to be up next. I'll share my screen. And this was a video that was, again, like I said, produced by Tony.
Hello, my name is Tony Schellink. I am an amateur astronomer and a member of the Royal Astronomical Society of Canada. This video describes to the beginner how to observe the moon. So, here's what we'll discuss. Why observe the moon? What is distinctive about the moon as an object to observe? How do we observe the moon? What can we see using binoculars or a telescope? And finally, sketching the moon's features when we observe the moon. So now, let's imagine a rogue alien planet has entered the solar system. And fortunately for us, it has started to orbit the Earth. Well, you can imagine what would happen. Everyone would run out and buy a telescope and point it to this new alien planet. What would they see? They would see oceans. They would see mountain ranges. They would see valleys and all kinds of other interesting things. Well, it just so happens we do have another large body up there that might be called a planet, and that is the moon. Most people don't realize this, but the moon is actually larger than any of the dwarf planets that are in our solar system. The only reason it might not be called a planet is it happens to be orbiting the Earth, and therefore we call it a moon. But it's certainly an interesting thing to observe and learn about in its own right. So why should we observe the moon? Well, as I said, it's an alien world to explore from our backyard. It's also very bright, so you can observe it right downtown in the city or out in the suburbs, even under the street lights. So you can see a lot of detail as the shadow moves across the surface of the moon each night, and therefore what you see in detail changes. You can see amazing detail with just binoculars or a small telescope, so you don't have to invest a lot of money in equipment. And there's a lot to see on the moon, so it's an interesting place to visit. Now, observing the moon is different from observing planets or observing other deep sky objects. Why? Well, first of all, it's very small in the sky. I know you've all seen it many times, and sometimes when it's near the horizon it looks quite large, but it's actually quite small. Compared to the planets, however, it is very close. It is also very bright, and so it is easy to see with a small telescope. And also, it is easily observed about 2 weeks of each month. The moon has a 28-day cycle as the shadow line or terminator moves across the face of the moon, which means you can anticipate what you can see along the terminator when planning your observing session. So how do you view the moon? Well, most of you think of viewing the moon through a telescope, and that is fine. However, I would recommend that you start with binoculars. You can see a lot of features on the moon using binoculars. However, a typical binocular view is about 5 degrees wide in the sky, while the moon itself is only about half a degree wide. So you can see in this diagram, the moon will be quite small in your view. However, the human eye is an amazing thing, and it can see a lot of detail by focusing in the middle of the view here. What would we possibly see? Well, first of all, you have about a dozen oceans that are clearly defined. You can see here we have the Sea of Crisis, the Sea of Fertility, the Sea of Nectar, the Sea of Tranquility, the Sea of Serenity, the Sea of Vapors, the Sea of Cold, the Sea of Rains, the Sea of Clouds, the Bay of Rainbows, the Sea of Moisture, and the Ocean of Storms. So by viewing the moon with your binoculars, you get to know all of these seas. Now, viewing craters is different. That's because we tend to look for craters along the terminator. And the reason is the peaks are highlighted as bright and the bottom of the craters are dark, which gives you a good idea of the shape and nature of these craters. So with a 4-day-old moon, we're going to be able to see these craters. And with a 7-day-old moon, other craters become visible, such as these ones. And again, these are visible using your binoculars. Other craters that are visible using your binoculars include these ones. So it's quite amazing when you look at it that all of these seas and all of these craters can be found and observed just using your binoculars. But if we want to get a close-up view of the moon, we really have to go to a telescope. You can easily observe the moon with relatively small aperture telescopes. That is, the size of the opening at the front of the telescope might only be a couple of inches wide. But we do want telescopes with a longer focal length. So you do not need big telescopes to view the moon. There are two basic types of telescopes. Those that use lenses to focus the light, called refractors, and those that use mirrors to focus the light or reflect the light. The latter telescopes include Newtonians and Schmidt-Cassegrain telescopes. Here we have typical Keplerian refractor telescopes that can be purchased at many department stores. The only drawback to these is sometimes you can see fringing on the moon. That is, blue on one side and red on the other, which somewhat obscures your view. However, that shouldn't stop you from having good views of the moon through these telescopes. Then we have reflector telescopes. The most common type is a Newtonian telescope. Here you have a large mirror at the back, and it reflects the light that comes down the tube up to a secondary mirror, which reflects it into the eyepiece at the front of the tube. Newtonian telescopes can be mounted on many different kinds of mounts. So here we have a German equatorial mount. The second one is called a Dobsonian mount, and this one is called an alt-azimuth mount. All of them work fine for viewing the moon. This little telescope down here is a little different in that it is a reflector as well. However, the light that enters the tube is reflected back to a stationary mirror that reflects the light back down the tube and out the back end. And this gives it a much longer focal length, and I'll discuss in a moment why that's and it mostly does away with fringing, but I don't necessarily recommend it for use in observing the moon. Well, you can observe the moon with one of these. Because it has such a short focal length, it's difficult to achieve very high magnification, and as a consequence you won't be able to see a lot of detail on the moon. So how do telescopes achieve different magnification? Well, first of all, the eyepieces that you use to look through a telescope come in many different sizes. The standard size eyepieces that are packed with telescopes are usually 25 or 20 millimeter eyepieces and a 10 millimeter eyepiece. So we will use these as our examples. The advantage of the 25 millimeter lens is that it has a lower magnification and therefore a wider field of view. Simply put, you see more of the sky with a lower magnification. This means if you're looking for something in the eyepiece, you should start with a low magnification eyepiece such as the 25 or 20 millimeter in order to more easily spot what you are looking for. If you decide you want a closer look at the object, then you center your target in the larger eyepiece and then insert the smaller one so that your target is still in the field of view. So the Keplerian telescope, a refractor, typically they may have 900 millimeter focal length. A reflector, such as this one, with the mirror in the front, has a light path that goes down to the back of the tube, up to the front of the tube, and then down to the back again. So even though it has a much shorter optical tube, the optical path inside of it is much longer. So this little telescope has a 1200 millimeter focal length. Now to determine magnification, we take our eyepiece, so in this case a 20 millimeter eyepiece, and we divide the size of that eyepiece into the focal length. So for the Keplerian, that's 20 into 900 will give you 45x, or a magnification of 45. For the reflector telescope, we divide 20 into 1200 and we get 60x. So you can see the advantage of a longer focal length. Now we take the second eyepiece, and it's only 10 millimeters, so we divide those into the focal length, and we get 900 divided by 10 gives us 90x, and 1200 divided by 10 gives us 120x. With this amount of magnification now, we will be able to see quite a bit of detail on the moon. The terminator is the area where the sun's illumination of the moon ends and the shadow begins. But it is not smooth, as you can see in these photographs. As the moon orbits the Earth, the terminator moves across the surface of the moon. The peaks of the crater edges are the first features to be sunlit and stand out against the dark background. The floor of the crater is still in deep shadow. However, the terminator actually moves quite quickly across the surface of the moon. So over the span of a couple of hours, you can observe the peaks of the crater rims as they come fully into view, and eventually the crater floor is illuminated. Once the crater is illuminated, however, it is difficult to see details of the crater, which is why astronomers like to view the moon's features that are on or near the terminator, so that the sun's rays are hitting at an oblique angle, and the bright areas and shadows highlight the crater's structure. As these features become visible along the terminator, interesting shapes may appear. One that is well known but appears every couple of months is the lunar X. In my photograph here, you might be able to make it out. Here, I'll help you. Now what this is are the rims of 3 craters that are very high and close together, so the sun illuminates them first. So it kind of forms an X, as you can see when you look closely, enough that it's worthwhile looking for and finding, and it's interesting. Rumor has it there's also a lunar Elvis, but I haven't been able to find that yet myself. Now this is me observing. Now my telescope's what you might call a medium telescope. It has, it's an 8-inch Schmidt cast grain, but I have a 10mm eyepiece in there, and I'm sketching the moon. Now what's interesting in this photograph is you can see that I'm right downtown. My telescope is set up at the end of my driveway. There are street lights everywhere, as you can tell by the shadows, and my neighbors have their lights on. It's about 7:30 on a March night, and I am happily sketching the moon. I was not the first to do this. Galileo in 1609 built a telescope, and one of the first things he did was point it at the moon. And of course, he didn't have cameras in those days, and he managed to sketch the moon. And this is what he came up with. You can see that he has the seas in approximately the right place. But when it comes to sketching the craters, well, he just drew in a bunch of craters. But this was a first. Up to this point, they thought the moon was just as smooth as a billiard ball. However, that was not the case. 70 years later, Cassini drew a second map. And this one, you can see a lot more detail in it. Well, he had better quality telescopes at that time. And you can see he drew in a lot of craters, and it was a lot more accurate when it came to sketching the seas. Now, I like to sketch, and so you saw me sketching there. Now, this sketch is not particularly pretty, but it has all the detail I need for purposes of observing. So what you can see are the areas that I'm going to leave bright white. You can see the gray areas, and you can see where the dark areas are. You can see the size and the shape of the craters. And you can also see where Mare Crisium is, Sea of Crisis. I also record information about my observing time and equipment. So we recommend that you sketch because it greatly enhances your experience observing. You get to see these shapes, the sizes, the juxtaposition of features, and it helps you remember what the moon looks like. So this is really observing when you're doing sketching. When you're sketching, you should record information about your observing. This would include the date, location, the equipment, as well as the weather conditions that existed at the time. So in this case, it was March 28th from 7:50 to 8:15 in 2020 in Halifax. I had an 8-inch Schmidt cast telescope on a CG5 Celestron mount, and I had a 10mm eyepiece in there which gave me 200 magnification. It was a cloudless night. The transparency was perfect, but the seeing was only average. That is, how much the air was bouncing around. So the things I was looking at on the moon were kind of shaking a little bit, but that didn't stop me from being able to see a lot of detail. So you should record this in a book and keep that as your logbook. The more sketching that you do, the better you'll become at it. And you'll create memories. And not only that, you can share these memories, as other people will be very interested in looking at your sketches. And when you return to these objects in future years, these sketches will be your guideposts. Here are some more of my sketches. And what you can see here is that there's so many features on the moon that you can sketch. It can fill many, many nights of observing. And you'll have the satisfaction of knowing that you're becoming an expert on what is on the moon. Well, I hope you found this video to be informative and entertaining. It's been a pleasure talking to you, and may you have many clear nights for observing the moon.
Tony's video is now available on our RASC Halifax YouTube channel, so if anybody would like to view it at any point or share it with your senders, if you are from away, please feel free to do so. It is there for your enjoyment and edification. So next up, and before our special presentation, is Paul Heath. And he is very well known for his expertise in presenting to youth, shall we say, Paul, because of his many, many years of volunteering with youth groups and with his experience as a school bus driver with youth that he encounters day to day. So Paul, you have a special youth presentation today?
Well, basically what I thought I would go over today is how to do a presentation and develop a program for youth. I'm in the midst, with COVID, of course, we're having difficulties having personal contacts for doing outreach for any groups. But with the Halifax Recreation Center now getting into after-school programs a little later in this month, we're looking at setting up an astronomy program. I've been trying to do this for over 10 years, and we finally got some connections with the Halifax Rec, and we're going ahead with the program. Now, basically, to do the program, we've got a group of 15 youth. Because of COVID, we have to restrict the numbers. But what do I do? What do I tell them? How do I present this? And I think the basics of most programs that I go into when I'm doing multiple talks with the youth, my first talk is going to be, what do you guys know? What are your interests? So I can present things like my solar system models, and we can talk about the solar system generally. We can go from there to questions about the sun, questions about galaxies, black holes, of course, that usually comes into it. Get an idea of what the level of understanding and desire of the youth that are involved in the program. What we're going to do in the second week, now each of these presentations will be about an hour and a half. The second week we're going to start to is, how do we see and what do we see? And I think I might steal Tony's little presentation on the moon. That was excellent on how to start them into looking at the thing. And that's the other thing. If you're working with youth, get your resources wherever you can. A little video presentation like that, or hands-on materials, things that are visuals, things that are hands-on, are the best way to go, I found. A big slideshow, you're not going to keep your whole audience. I mean, it's nice to have lots of great pictures, but you want to get some things presented where you start working hands-on. So we've managed to collect enough binoculars so that each of the youth in the, and this is because of COVID now, we have enough binoculars to be able to go ahead with this program. So each youth will have their own binoculars. So we'll start with what is the binocular, what does it show you, how to focus the binocular, and then what can we look at. So this will be the beginning of the second week. And also I'll introduce different telescopes. I've got a couple of small telescopes that I can show them the types of telescopes and give them an idea of what we might be able to look at. The third week, we're going to go into constellations. And if you've seen my talks before, you know I've got posters that have done up with constellations. We have the star finders that the youth use. I should have had one here. I don't know if you got one handy, Judy. I guess like a star finder like this. We'll begin with what they show and how to use them, so that the students can start going out themselves and start looking for various constellations. And a craft where we're going to make our own constellations, or we're going to see about doing up the constellations that we see in the night sky. We're hoping to be able to go outside and do observing a couple of times over the 7-week period. Then we go on to the solar system. Again, we'll talk in a lot more detail about our planets in the solar system, where we could find life, introduce concepts like the life zone of a star, introduce concepts of what is a gas giant, what is a rocky planet, asteroids, comets. We can introduce all the various objects that we'll be able to see and look for in the night sky. Then, of course, the fun one with kids is aliens. So in week 5, we're going to talk about where do we think we're going to find aliens? It's like which stars have planets within the life zone of that star? What would an alien look like based on the kind of planet that we would find? And we know from the Kepler data that a lot of stars have planets, and the planets are various within the hot range and the cold range, or in the center of the life zone, around multiple stars, around white stars, giant whites, red stars, dwarf stars, or stars like us. And you can take it the next step further. I've done 2 situations where we have a list of planets that are around other stars, and each of the youth begin to be represented. So they become a delegate to a planetary conference, and we start with their sun, talk about their sun, talk about the planets around their sun, and then we look at what do they look like? What does the alien look like around their star? So we can incorporate a lot of physics, a lot of biology. How does things live in different types of environments, like a water world or a gas giant, and that. Explore and try to engage the youth as much as possible. The following week, the 6th week, we'll talk about stars, how they're formed, their life cycles, what will happen to our sun. Again, I have demonstration materials that allow me to actually show what is going to happen to our sun. And then the next one, we go into programs. The last week, we'll introduce things like Explore the Universe program, Explore the Moon program. During the 7 weeks, this is Nova Scotia. We're hoping to get out at least twice in the 7 weeks to do observing on the Friday night. That will stretch to whatever our observing time, like we could do an hour or 2 hours depending. But there, the kids will have the opportunity to use the binoculars and start finding the constellations we were discussing, start looking at the moon, start looking for planets, and go from there. The main objective with any youth program is to excite them and to get them to want to do more. So you get a little bit of classroom type work, a little bit of hands-on type work, and then with luck of the weather, you get them outside actually looking at the night sky. And it's a simple, straightforward program. I'm doing an hour and a half each of 7 weeks. And if it's successful, we've already been told we can do it again. So with any luck, this will turn into a regular full-time program through the Halifax Rep. But anyone that wants to set up a program for youth, you want to gather your materials for crafts, crepe paper, styrofoam balls, lots of glue, pipes, cleaners. Aliens always have antennas, so you need to be able to make antennas. Make antennas for the kids. Get your craft materials, or I'm lucky in the regards that the person coordinating this has the funding to buy the craft materials. So each of the weeks you have a small little thing that the kids can produce, like the map of a constellation that they're going to make, or make their own aliens, or make their own star. A balloon and tissue paper is the best way to go to make a model of a sun. So there's lots of little things you can do. Set up your program in advance so that the kids know each step, so they want to come back the next time. Always have something hands-on each week that they can work with. And if at all possible, if you're lucky enough with the weather to cooperate, you can get outside and do a bit of observing. We're going to look at the planets maybe one night. We're going to look at the constellations another night, and then maybe look at dark sky things. So, I mean, COVID's restricted a lot of what we can do, but I think this is going to work, and we'll be able to actually develop a good program for a small group of youth and get them hooked or really keen on looking up at the night sky. So it should be fairly straightforward for anyone to develop. And with any luck, we're going to have a whole bunch of kids, because they're stuck at home, they might want to look up and become astronomers. Thanks, Judy.
That's great, Paul. Sounds exciting. Let's hope that COVID doesn't do anything to change the schedule for this program that you've got.
Yes, so long as they keep the rec center open, we can do this. If they close it down, then we're sort of stuck. But yeah, we're keeping our fingers crossed we can expand this to actually we've got interest from the other two community rec centers at the moment. So hopefully we can spread this around and do it in a number of communities. Great.
Well, thank you so much for that.
Okay.
Okay, so now we come to our main presentation. I will state up front, we didn't search out our next presenter. He sought us out, and we're really thrilled that he did. Lauchie Scott is a native son of Nova Scotia, so we're welcoming him that way. But he's also the principal investigator of a space object tracking mission on the NEOSSat microsatellite. And I'm reading this simply because I'm not familiar with the terminology, which I'm sure Lauchie will explain to us. And he's going to discuss why the Canadian Forces care about space in terms of tracking it, in terms of mapping it, in terms of all sorts of aspects. And I've had a chance to briefly preview what he's going to present. And so I know that you will find this really exciting to listen to. And so I'm not going to give any spoilers. So without any further ado, I'll hand it over to Lauchie. Thanks, Lauchie, for joining us today.
Oh, thank you very much. And I really appreciate the opportunity to speak to you today. So I'm just going to need a second here just to get my desktop to present on your screen. I'll just give you 1 second here. Actually, just hold one. I have a little technical glitch here that I just have to resolve. Just need to, where is the key for projecting my screen? Yeah.
It should be.
Oh, there it is. Oh, there we go. Thank you. And just a quick technical check. Can you see my desktop right now?
Yes, we can.
Perfect. Okay. So I'm going to give a bit of an overview of some of the R&D that we've been doing at Defense R&D Canada, Ottawa. I'm a scientist there, and I'm very pleased to be giving this presentation today. I've been meaning to do this for quite some time, actually. So I'll be able to give a bit of an overview as to what exactly we do and what those strange little points of light are that fly through the sky when you're observing on any given dark night. That is the topic that I spend my entire career looking at. I look at space objects and in particularly space junk. So I'll be giving a bit of an overview as to what exactly this is, and I'm very, very happy to be able to do this for you today. I have a question and answer box open here on the right, so if you like, feel free to drop a question in there. If it's good timing, I'll try to address it and answer the questions as they come in. So just a very quick primer about myself. I'm a defense scientist for Defense R&D Canada. We're basically the R&D arm of National Defense. I'm originally from Thorburn, Nova Scotia. I'm an Acadia and Tons engineering graduate. While I was at Acadia, Roy Bishop and Larry Bogan taught me some of the basics of astronomy while I was there. So it was actually it was actually a very neat way to get introduced to the field while I was studying engineering there. Space situational awareness, I'm the lead for Canada in this particular area. We concern ourselves with things in outer space, the security environment in outer space, and it is becoming a very, very congested and polluted environment now. So it's not something that really crosses people's minds when they think of the sustainability of the environment. When you're looking out into space, usually you don't see a problem, but the reality is it's there. And I'm going to try to give a little bit of an elaboration as to why it's a problem and why Canada cares about it more broadly. I'm also the principal investigator for the NEOSSat microsatellite space situational awareness mission. This machine that you see sitting behind me here is the microsatellite that we control every day. And there's actually a telescope that on board that we use for tracking space objects. And I'll give you a bit of an overview how we use telescopes that not really that much different than the ones that you guys use for observing the sky, but we repurpose them for tracking space objects and some of the extreme environments that we do it in. My agency is Defense R&D Canada. We're the R&D arm of National Defense. We do applied R&D for pretty much any area of national defense, whether it be space, maritime, land, sea, or cyber defenses for Canada. About 1,400 employees. We have about a funding limit of about $300 million per year. Our headquarters is in Ottawa, and we got 5 labs across the country. My facility, DRDC Ottawa, is located on the Carling campus, which is in Shirley's Bay, just west of downtown Ottawa, Ontario. We're sandwiched in with the Canadian Space Agency and the Communications Research Center. And our facility is actually located on the north part of the campus under the red blob that you see here. We have quite a few assets on site. We do have a robotic telescope on site that we use for research when we track objects in outer space. We have quite a few antennas that we can query space objects using radio frequency techniques. And just 1 second. Oops, sorry. Using radio frequency techniques. And we also have quite a few assets in space. NEOSSat access to Sapphire and the M3MSat maritime surveillance microsatellite also. So why are we concerned about space? Well, the Canadian Forces has quite a few assets that they rely upon in outer space. And this graphic here is basically showing you the extent of the environment right now. There's about 20,000 objects that we can track in outer space. Those are objects bigger than 10 centimeters. We think there's actually closer to 1 million based off the statistical studies that we've done. And this is important because there's 99% of what's out there is stuff we can't control. It can't be flied. It's just junk. And what that means is that when we have all kinds of important assets that the Canadian Forces, or for most part, the society in general, whether it be GPS satellites or SATCOM satellites, weather, missile warning, or overhead imagery, those are all services that the Canadian Forces cares about. Every one of those capabilities are extremely expensive, and they're basically flying through an environment where there is a lot of space debris now. So SSA is that unique practice of tracking and characterizing the orbits and characteristics of those space objects out there and predicting what's going to happen. The prediction problem is tough. We can't take enough measurements of these objects to reliably forecast where they're going to be in the future. And as a result, we have to keep tabs on them. It's kind of like predicting the weather. A forecast for tomorrow is usually pretty good, but a week into the future, that forecast gets progressively worse. We have the same problem when tracking space objects. You have to stay on top of them, otherwise you lose what we call custody of them, and we lose them in space. And this is why this field is important, because these things are a risk to satellites. The environment is changing too in outer space. Probably not too broadly known, but when the Chinese tested their first anti-satellite weapon back in 2007, a little less than 2 hours after that event, the RADARSat constellation, or sorry, the RADARSat 1 satellite started grazing the outer edges of that debris cloud. As far as we know, the RADARSat did not get hit, but it did not take long for that event to start having an impact on RADARSat. And RADARSats subsequently to that event had to start doing what we call debris avoidance maneuvers. That's basically a very tuned maneuver that basically move out of the way of space debris. And this is a problem that we face on orbit right now. So it's a security environment that's changing. It's becoming more and more polluted, and it's becoming a bigger tracking problem. The Canadian Forces operates satellites in space, Sapphire being one of them. As a matter of fact, shortly after we launched Sapphire, Sapphire actually came very close to a debris fragment from a US meteorological satellite, and it flew within 44 meters of that space object. The closing speed was about 15 kilometers per second, roughly. Well, if it had been at sea level, that would have been Mach 50. So if those two actually had contacted each other, it would have obliterated Sapphire, an $80 million Canadian investment in space, and would basically have eliminated that space asset. So that's why this is so important to keep on top of. The objects we put there are quite expensive, and it's very hard to predict where those small debris objects are all the time. Those bubbles you see around the satellites in this particular graphic here, this is the whole name of the game of what we do. Those bubbles are how uncertain we are. So the bigger the bubble, that means the less certain you are where that satellite's position is. The whole name of the game is to make those bubbles smaller. And if they get small enough, it's fair, we can usually say whether or not we got to do a maneuver or not. If they're too big, we don't know for sure. That's basically how this plays out. Now, the risk involved in this is that since these things are traveling so fast, a 10-gram nut or a bolt that's flying around in outer space, if it closes in on a spacecraft and hits you at 15 kilometers per second, it's got the same impact energy as a truck driving down the highway at 100 kilometers an hour. So you can understand that there's a huge amount of energy tied up into these things. Such a small, tiny little fragment can do an enormous amount of damage. And what you see in this picture here is an ESA representation when they did a hypervelocity impact of a small pellet onto an aluminum block. You can see the damage that it can do. So these are the kinds of risks that we deal with on a day-to-day basis. So the Government of Canada has an engagement in SSA going back actually quite a few years. Canadian Forces used to actually run what we call Baker-Nunn telescopes in Cold Lake, Alberta and St. Margaret's, New Brunswick. In the 1990s, we moved into more of a NORAD support role. And more recently, Canada has launched the Sapphire space surveillance system to track objects in space. Today, we've got a bit of a changed mission. The Forces has what we call a protect and defend role for both Canadian and allied satellites. So SATCOM satellites, GPS, the ones that we own or other interests of Canada are all fall under the mandate for the Canadian Forces to have a responsibility for defending them. Defense R&D Canada, we're a applied R&D facility where we do quite a bit of testing and development in support of the Canadian Forces. We develop ground-based telescopes for test and evaluation of that, and I'll talk a little bit more about that in a second. And we also run a small research vehicle, NEOSSat, on orbit, which I'll get into quite a bit later on. The Canadian Space Agency, they're an operator for the Government of Canada. They operate the fleet of Canadian satellites for research and for overhead imaging, such as the RADARSAT Constellation mission. And they do regular assessments of what they call conjunctions on orbit when two satellites are about to close in on one another. So you may hear the word conjunction floating around quite a bit. It's got a different use in the space surveillance community. It doesn't mean all things that look like they're close together. This is a risk of these things might actually hit each other. And that's the kind of employment that we use for that term when we're looking at the risks to objects in space. So this is a NASA picture of debris objects in orbit, and this is why you see those streaks going through your astrophotography images from time to time. There's a lot of stuff out there, and there's a lot of stuff that we know is there that we just can't track. We break up the environment in two parts. Low Earth orbit goes out to about 1,200 kilometers altitude. There's a lot of satellites there. The satellites such as RADARSAT and even NEOSSat for NEOSSat, they fly within 800,000 kilometers of within Earth's surface. So they're pretty close to the Earth. The ones that are further out are called geosynchronous satellites, and that ring that you see going around the Earth is a very special orbit. It's a very special piece of orbital real estate that if you put a satellite in that orbit, it follows the Earth and does one rotation every day. And it makes it real easy that if you bolt a a dish on the side of your house, like your satellite dish for satellite television, it only has to point in one place, and it can always talk to that satellite for broadcast television. And that's the utility of that orbit. It always sees the same geographic place on Earth all the time. So this is how we break up the orbital regimes primarily for space surveillance. And this is what and you're going to see me reflecting this throughout the talk here. Canada is affiliated with the US Space Surveillance Network. It's a worldwide network of telescopes and radars that track objects in outer space, and it's run by the US Air Force, or now actually the United States Space Force. So there's actually a very large set of military capabilities which watch outer space. Low Earth orbit is primarily handled by what we call phased array radars. These usually track and look for they have a missile warning duty, but 99% of the time they're actually watching space junk in orbit, and they continuously report on debris objects in outer space. For deep space, those objects out in geosynchronous orbit, the US Air Force runs an array of 1 meter optical telescopes. They're short focal length, wide field, but they're extremely sensitive. And these systems are located all around the world to basically keep tabs of that geosynchronous orbit. I actually got to stand in the observatory with one of these when they were testing one, and it was actually pretty remarkable to see those big direct current drives running this multi-ton telescope around. It was actually a pretty impressive instrument to watch. Canada runs space surveillance instruments too, but we use smaller aperture optical instruments to do so. And recognizing and reinforcing what I've heard earlier on the telecon today, Canada has a lot of clouds. We get it. So we put our telescopes in space where there are none. Now it's a very unique environment to track space objects by doing it this way. And the advantage is that you don't have a day-night cycle. You can run that telescope continuously. You don't have to worry about daytime sky and so forth. And also, you don't have to worry about the atmosphere attenuating your imagery when you look lower on the horizon too. That's the reason why we put them in space. Sapphire, the satellite you see on the far left, it's about the size of a dishwasher, but it's the operational capability that the government of Canada contributes to the space surveillance network. And it runs it's actually a 13.5 centimeter telescope behind that red end cap that you see on the screen there. And that basically, this sensor is continuously producing tracking of those space objects that I was telling you about earlier. It's operated out of 22 Wing North Bay, and the data is sent direct to the US Space Surveillance Network day in, day out, and this sensor has been running since 2013 when we launched it. NEOSSat is a smaller version of Sapphire. It's what we call a microsatellite. It's about the size of a suitcase and weighs about 70 kilograms or so. So it weighs about the same as my suitcase when I get loaded up and pay those extra fees to Air Canada whenever they find those extra fees to Air Canada. It's a dual mission microsatellite. We're partnered with the Canadian Space Agency. My role as a PI is to look at space objects in outer space using NEOSSat, and putting a sensor in space to do so is a wicked place to do it. There's some pretty cool stuff that we're doing now. The other mission is doing astronomy. Originally, they were doing asteroid astronomy, but we've actually moved into a little bit of exoplanet astronomy with this vehicle as well. And we can see objects down to about magnitude 16, which is pretty deep into outer space. We can look, that basically means we can see a 1 or 2 meter object 40,000 kilometers away. That's how deep into space we can look. Ground-based optical is another set of sensors. The one you see on the right is a sensor that we operate here in Ottawa, and it's basically built on high-end amateur astronomy equipment, but we got a little bit of an advantage that we put high-speed cameras on the back focal planes of these instruments, and we use them quite frequently for tracking LEO objects now when there's something interesting going on. So what does the imagery look like? It's not as pretty as what you guys see when you're taking astrophotos. So this is what 3 geosynchronous satellites looks like in outer space. I hope this image is reproducing well when it's broadcasting. The streaks you see in the background are background stars. And those dots you see are 3 Canadian geosynchronous satellites slowly migrating around each other out in deep space. And they're about magnitude 10, magnitude 12, depending on the time of the night that we're observing them. The way that we do this business is that we measure the center points of those point sources, the satellites, and we freeze the frame to, just one second, I'll pause it here. And we freeze the frames and we take the centroids of each of those streaks as well. And since the astronomers have taken such high accuracy measurements of the stars, we can pinpoint the location of those satellites to within about 200 meters, 40,000 kilometers away. We take those measurements, we send that to the US Space Surveillance Network, or we process the orbits internally in Canada, and we can pinpoint those satellites down to within about 50 meters if you have enough data built up over time. So it's a pretty precise way to actually measure the positions of space objects out there. I'm going to talk a little bit about ground-based optical. This was the first project I was assigned at Defense R&D Canada. This was actually a risk reduction system for Sapphire, where we built 3 robotic telescopes to track space objects in deep space. The telescope's objectives is that they're fully automated. You give them a tasking list, the domes open up on a clear night, and they start snapping pictures, looking at the sky, and they would take imagery like you just saw here a moment ago, and they automatically reduce the data, and it shoots the imagery, sorry, it shoots the observations of the satellites to the US Space Surveillance Network. We actually ran this operationally for a few years just prior to the launch of Sapphire. One of the interesting things that we have to do for the Canadian environment is that we have to ruggedize the robots to work at minus 25 Celsius. So you're doing a lot of changes and adding heaters or putting low temperature greases in a lot of the mechanical parts in order to make sure they're robust enough to handle the extremes of the Canadian climate. Our Suffield sensor out in the prairies in Alberta, it had a different engineering problem. We were getting regular sabotage out there for a little while. So we had to reinforce that one with physical security because the antelope tended to love to eat the GPS cables off of the antenna mast that we had out in the field there. So it was there's different challenges when you're trying to do space surveillance. Suffield's a fantastic place to do it. It's nice and dark, clear, nice, dark, clear skies quite frequently out there, but the antelope tended to love to chew the cables off all the equipment for us out there. A little bit of aluminum piping fixed that up. So I'm going to talk about an interesting event just happened a couple of years ago. Periodically, satellites do go out of control and they start drifting out in geosynchronous orbit. And I'm showing you an example here. At the very top of this image, you'll see AMC-9. That's actually a satellite that spontaneously just kind of jumped in its orbit by 10 kilometers and started drifting towards Canadian satellites. As a matter of fact, NMIC-6, one of the satellites that's used for television broadcast, basically was at risk of this for a short time. Just one second, the chat box isn't showing up. But anyways, you'll notice something different about this satellite is that it's changing, it's twinkling. And if we measure the photometry coming off of that satellite, I can look at this plot and I can tell you immediately that satellite is uncontrolled. So we don't just measure the position, we're measuring the brightness as well, because that's a big tattletale that tells you whether or not a satellite is controlled out there. I know what a steady satellite or what a controlled satellite looks like. It actually has this nice, smooth, monotonic light curve. This one here is obviously not, and we can basically measure the photometry to basically figure out if an object's controlled or not. I have to apologize. I see there's a couple of chat things coming in here, but for some reason it's not appearing on my screen. So Judy, I'm not sure if there's a way to announce if there's questions that's coming in, but if you do, feel free to hop in if you see some that pop in.
Yeah, there was a question regarding the NEOSSat telescope, whether or not it was a Saravolo scope.
Actually, no, it has a little bit of design lineage. I know Peter Saravolo, I talked to him and we tried to contract him actually for the NEOSSat optics several years ago. The instrument actually came from Spectral Sciences in Mississauga, Ontario. Sorry, Spectral Applied Sciences in Mississauga, Ontario, and it shares a similar design, but it's not the periscope. Not the periscope design that Peter designed for the MOST microsatellites several years ago, but it does share quite a bit of design lineage there. That's a very good question. So I'll mention a little bit more about NEOSSat as we go on here. So you're probably wondering now, there's a lot of things going on in space, and it kind of looks like there's a lot of ping pong balls basically bouncing around and flying around out there. Well, we're actually investing in technologies to try to reduce the risk of objects being on orbit perpetually and causing a risk to other spacecraft. Back in 2017, well, actually in 2010, we sponsored the development of the CanX-7 nanosatellite. It's about the size of a bread box. It was just a little test R&D satellite that University of Toronto built. And it had a very unique payload on board. It actually deployed drag sails. And the whole idea behind this little satellite was to deploy these sails, grab that thin, tenuous upper atmospheric particles or upper atmosphere particles and use that to drag yourself out of orbit and descend. It was a very unique experiment, and we're actually pretty happy to say that yes, it is deorbiting right now after we tested this drag sail. One thing that's we're starting to see the appearance of is that small satellites are becoming dominant in low Earth orbit right now. They used to be a rarity, but now that we're starting to see them used by a lot of private corporations worldwide right now. And one of the issues with that is that they're very small and compact, and they're very, very dense. And it's just like a cannonball on orbit. So if you have a cannonball on orbit, it'll tend to stay there in that drag environment much, much, much longer than a lighter object is. Similar to taking a piece of paper, crumpling it up and throwing it against the wind, well, it slows down more. A baseball, of course, is denser. You throw it and it goes further for much longer. We have the same principle in high Earth orbit. So we paid for the development of this nanosatellite to test the deployment of a drag sail. Now I'm going to show a video here. I'm not sure if the audio is going to come through or not, but we actually took observations of the drag sail deployment. We can't see the drag sails. It's still too far away for our instruments. It's just too small of an object. It's about 4 meters across when it's actually deploying the sails, but you will hear the satellite operator, hopefully if the audio is going to broadcast. And you'll also hear the other telescope that we commissioned in Kingston and the one I operate in Ottawa, trying to observe the drag sail deployment. So we'll see if the audio comes through here.
I am arming the
Is the audio coming through on your end, Judy?
Sails armed. Sending the
So what you're seeing in the top left is telescope measurements in CanX-7, and you see the live light curve there.
Whoa.
Our first drag sail deployed, and we saw an immediate step
Magnitude
change in
increase of 2, just brightened by
CanX-7.
2 magnitudes.
CanX-7 was flying over Nova Scotia actually at the time when we
RMC, can you confirm brightness increase?
Images of it.
Go definitely,
Excellent. We confirm optical change on CanX-7. Looks like your first sail deploy, guys. Congratulations.
Our deployment's really good as well. Yeah, mine is still strong.
So I'll just pause it right there. One of the neat things is that when we deployed the second drag sail about a couple minutes after the first, the object actually became naked eye visible. So it didn't take much for that little satellite, when it deployed a reflective surface on board, to become visible. As a matter of fact, it saturated our instruments. We had to dial back the exposure of our instruments in order to track this thing. So it doesn't take much for a small object, a few hundred or 700 kilometers up, to actually increase its brightness such that it becomes something that you see visually. So talk a little bit about Sapphire. Now, Sapphire is the operational capability of national defense. It's a deep space surveillance telescope that tracks primarily geosynchronous objects and also for rocket bodies and other large space objects that are out there. It's about a meter cubed on a side, about the size of a washing machine. And the orbit is in a sun synchronous 786 kilometer orbit. It's actually, we launched it with NEOSSat to orbit, and I'll show you what that looked like when they were stacked together on board. It does about 360 tracks per day, but that roughly works out to about 3,000 images. It's always running, about every 10 or 15 seconds, this thing is always producing imagery against the background sky. It's designed for a lifetime of 5 years. We're actually over lifetime right now for this vehicle. And right now we're looking forward for its eventual replacement. And it's actually producing very useful data. And it was a very strong contribution to the US alliance that we're a part of when producing space surveillance imagery. Now, like every satellite, there's a ground system that goes with it. We have 2 antennas, one in England and another one in Abbotsford, British Columbia. It downlinks, Sapphire downlinks its imagery data. It's processed in Abbotsford. It's sent off to our NORAD facility at 22 Wing North Bay. And from there, that's transmitted down to the Space Surveillance Network. And we receive taskings going back up the other direction through the return path. And that's how we run the Sapphire system. It's a very, very capable machine. And it's actually very, very accurate as well. As a matter of fact, we made it about 3 times more accurate here just a few years ago. So it's an increasingly important capability that Canada provides to the Space Surveillance Network. NEOSSat's my baby. I've been working on NEOSSat since I first joined DRDC about 18 years ago. So it's a small satellite, it's a dual mission microsatellite that we developed for both SSA, Space Situational Awareness Research, and also to do astronomy. It's a joint project between ourselves and the Canadian Space Agency. Our prime contractor was MSCI in Mississauga, Ontario. And the reason we got the money to build this was that we started building this microsatellite at a time when nobody really trusted these things. Microsatellites were new back in the early 2000s. Everybody was used to the big capability systems that were put to orbit that cost $1 billion. NEOSSat was less than 25 million. It's a much smaller capability, and we do a lot of design choices on board to try to ensure that the system works well on orbit and functions reasonably in a very harsh radiation and temperature environment. It's pretty tough to design them, and there was a lot of very talented people that put their heads together to build this small space telescope. We had 2 primary objectives. One was to test the military utility of a microsatellite to see how well it worked, and the other was to do experiments that you can't do from the ground. Being in space offers you a huge advantage when you're looking at space objects. I'm going to show you some pretty awesome examples of that here in a second. So this is what a satellite looks like when you undress it, actually, and you take its solar panels off. The telescope is in that left portion of that baffle that you see that's stretched out to the left, and we actually chamfer the baffle by 45 degrees so that we can look very close to the sun. The reason we do that is that the astronomy asteroid mission wanted to look for what we call Aten-class asteroids. These are asteroids that could cross our orbit. And the vulnerability is that usually they're coming out near the sun. So we had to design the instrument to watch for those special objects coming towards us near the sun. So that's a very hard design problem, because you have to chamfer the baffle to make sure that light rays from the sun don't actually bounce down the telescope tube and basically impinge on your detector. Or the other thing is that we had to actually put very, very, very high absorption paints inside there. And it's actually kind of weird. If you look inside the telescope baffle for NEOSSat, you don't see anything. It's completely black. You can't see any physical structure. It's actually really creepy to look inside the thing. You can see the mirror hanging in kind of like out in space and hanging in space behind there, but you can't see anything else in there. It's kind of odd looking at that very matte black inside. The telescope sits under that tinfoil-y substance that you see there, which is thermal blanket. And the telescope is sandwiched underneath there, so that it's a small 15 centimeter Maksutov that we use for tracking. We have a CCD on this instrument, and we use a radiator to bleed heat away from that CCD to cool it to around minus 30 Celsius. We don't have air in space, so we can't use fans or thermoelectric coolers to bleed off heat. So we use conduction and a radiative surface to cool the instrument, and that's how it works in outer space. So there's some very interesting design chain choices that you have to make. The payload computer and the avionics and all the other brains of the satellite sit in those aluminum boxes at the very base, and they form the backbone of the satellite as well. You tie rod all that together, put the solar panels on, and you've got a satellite that's ready to go to space. One thing I can't really convey here is that there's a lot of radiation hardening that goes on as well. You design your parts to be tolerant to a very, very hot radiation environment. That's something you usually don't think about when you're using CCDs on the ground. Every once in a while, you'll get like a little cosmic ray hit. In space, it happens continuously, and I'll show you some videos of that shortly. So NEOSSat, we launched it with Sapphire from India in 2013. You can see on the left here, Sapphire and NEOSSat being stacked under what they call a launch adapter. It's kind of like a clamshell that you clasp down on top of the vehicles, and when you get to orbit, the shell actually detaches and springs kick both NEOSSat and Sapphire away from the upper stage of the rocket. So it's a pretty neat way that you actually stack a whole bunch of satellites together. That gold-looking satellite there is called the Soral satellite, which is a French-Indian remote sensing mission that looks at the Earth and does all kinds of interesting things. We look at it periodically just because it's big and bright and fun. But anyways, this is how you stack satellites together when you put them together for orbit. Once the DLA and the launch adapter is closed and the clamshell is closed, then you put the fairing around the upper stage. Once you crane that to the top of the rocket, you're good to launch, and we launched on the 25th of February. So it was actually a pretty impressive day. I wasn't there to witness the launch. I was actually back in Ottawa looking forward to the first telemetry from the vehicle when we got to orbit. So one of the things I want to convey is that the period between launch to getting that first contact from the satellite's about an hour. And that's when you're really, really, really biting your teeth. You want to know if that thing's going to call home, because you're just curious, did I just launch a $25 million brick into space? So you're actually kind of on pins and needles waiting to hear whether or not it called home. Thankfully it did. It called back, and we had 2 ground stations that immediately picked it up as soon as we flew over. And we started beginning the science mission and the commissioning phase afterwards. So NEOSSat in a 785 kilometer altitude orbit. It's pretty close to the Earth, but we look at geosynchronous objects much further out, and we can pretty much look anywhere on the sky. The one place we don't, though, is within that red solar exclusion region. That points towards the sun, and our orbit is usually roughly 90 degrees away from that area. We can look anywhere else. We can look inside that solar exclusion zone a little bit, depending on the season, time of year, and how we orient the vehicle. But if we look in there, there's actually a little sun safety shutter that snaps shut, and you have to get an operator to go to the CSA and actually tell it open back up again. So usually don't look in there because you don't want a telescope looking at the sun, especially if you have no way to service or repair this thing in outer space. So it's one of the reasons why we have these go and no-go regions for operating the satellite. But other than that, we take imagery all the time with the vehicle. So, and this is some imagery that we've taken from NEOSSat that you see at the very bottom, actually. This was actually a multinational experiment that we just completed earlier this year, where we had the United Kingdom, the United States, New Zealand, and Australia all tracking a geosynchronous satellite that actually docked with another satellite out in geo. This is a very, very, very new thing. We don't usually can think of satellites that are actually servicing other satellites. That technology's here now. And as a result, there's both benefits of this potential technology that we can see. We could have very good benefits for servicing and extending the life of satellites, but we also have the other side where it could be used for more nefarious purposes or security risks. So we test and evaluate what are the limits of our capabilities tracking it. The video you see at the bottom where we're tracking Mission Extension Vehicle 1, the servicing satellite, and about a 15-year-old communication satellite called NEOSSat 901. The two satellites cozy up to one another, and actually if you see in the imagery, you can actually see them getting closer together. So we're starting to see some unique things out in orbit right now because the technologies are really accelerating rapidly. On the right side of the screen, you'll see a satellite not taken, or a satellite image that was not taken by NEOSSat. It was taken by Mission Extension Vehicle, actually, and Northrop Grumman was kind enough to let us see what NEOSSat 901 looks like on orbit. So what you're seeing is a satellite being imaged from about 50 meters away as the other satellite was basically approaching it from its back end and getting ready to actually dock with it. Meanwhile, we're watching the two dots getting closer together from space. So this is the type of imagery that we collect, and we track these objects to basically see what they're doing on orbit. And this is what we do on a day-to-day basis. So I mentioned conjunctions earlier, and again, conjunctions for us are not really just pretty celestial events. They're actually very threatening. So anyways, in this case here, we're actually looking at space objects. Well, it's actually the Spot 2 satellite, and we decided to watch one flying towards us, and this is what we see from NEOSSat. This is a large satellite that was actually barreling towards us, and the image you see in the top right is what the telescope looks like what the telescope sees when you point NEOSSat's instrument into the relative velocity vector of that oncoming object. And you see the object brightening as it gets closer and closer and closer. So we're starting to do some neat things in low Earth orbit now. This here is an image of a much smaller object. This is probably about a foot across. It's a piece of a rocket body that exploded several years ago. And you can see that it starts out looking like a star, but then it suddenly veers away and goes below us. It missed us by about 3 kilometers. And objects do get much, much closer, but there's a lot of objects flying by us continuously in low Earth orbit. And we're starting to take a lot of tracking data now characterizing objects in low Earth orbit and in geo. So we're starting to see some pretty unique things as we continue experimenting with the vehicle. I think some of you may have heard of mega constellations. SpaceX, Amazon, Telesat, and Boeing are all starting to make proposals now about putting very large space infrastructures in space, which is basically covering the entire Earth with thousands, if not tens of thousands of new space objects. And in the astronomy community, quite a few people have reported seeing these things visually as trains of dots against the night sky. And there was quite a bit of concern actually raised about how is this going to impact astronomers who are using wide field instruments on the ground looking for asteroids that could be risky to the Earth. And that's legitimate. There is potential concern there because the SpaceX Starlink satellites were obvious when they were launched. They were naked eye visible in a lot of cases. Well, we are watching Starlink from we're actually about 200 kilometers above the Starlink constellation, and we watch Elon Musk's satellites and we characterize them from up there. It's actually a very good test for us. Mega constellations are a new thing for us as well. And one of the things we're finding is that there's a lot of work to do because there's a lot of objects to track all the time. And we're starting to watch them much, much, much more frequently. And what we see from a Starlink is, oops, go back one here. Oh, my video is not playing on this one, my apologies. The Starlink satellite is actually that dot you see inside of that little tracklet there, and you see the streak stars in the background. Like I mentioned earlier, there's a lot of these things, and this is an example of what it looks like. We've actually characterized about 247 of the Starlink satellites now, of about 1,500 observations, and from orbit, we see them as around magnitude 6. So it's just borderline naked eye visible from what we see. It wouldn't be the same thing necessarily that a ground-based observer would see, because a ground-based observer looking at a Starlink would look from below, and they would see a different finish of the satellite. They would see that bottom face of the vehicle. Whereas on orbit from NEOSSat, we're looking from above, and we primarily see the main solar array, which is about a 30 square meter area. So we see something that's a little bit different on orbit. So we're starting to characterize this, and I have a young captain that's compiling a big analysis of the Starlink brightness characterization right now, and we're going to be releasing that at a conference, a Canadian conference in November here. So there's more to come right now, and just a little preview of what we're starting to see on orbit right now of the Starlink satellites. So I promised a little bit of astronomy here. We don't just do satellite tracking with NEOSSat, we do quite a bit of astronomy. There's 2 missions that the astronomy team at the Canadian Space Agency executes. It does exoplanet observations. University of Bishops, Jason Rowe at U Bishops is looking at stars to basically watch planets crossing the disk in distant solar systems. It's actually pretty neat what he's able to do with the vehicle. Minor planets, University of Victoria, there's a observer out there, David Balaam, who is doing minor planet tracking fairly often. We are registered as a observer for minor planets with the MPC, or Minor Planet Center, as observer C53. And if you wanted to look at NEOSSat imagery, you can go right to that FTP site, and you see pretty much the same thing I see. It's the same FITS imagery that I think some of us are familiar with when you're taking astronomical imagery. Under the open data policy for the Canadian government, we release the astronomy images to the public. And you can look at the astronomy data for various space objects that the astronomy team looks at. Just for fun, I had one of the young captains do a mosaic of the Andromeda Galaxy from space, and this is what he saw. Now, we have quite a few blemishes on our detector that we have to correct for and so forth, but yeah, it was a lot of fun. We take pictures of nebulas from time to time just to try out the instrument and so forth. But for other astronomy stuff that we do, the One Asteroid campaign that I did participate in 2012, we tracked a 10-meter asteroid that came within about 55,000 kilometers of the Earth, and NEOSSat tracked it just on the day side, as you right about here. This is where we were doing most of our work, actually. The asteroid you see in the lower left, there's actually that little dot that you see in the streaked imagery, and the intent of this experiment was to participate in a worldwide campaign to track this object to figure out where exactly would this thing pass the Earth. And the big observatories nailed the position of this object down to about a 100-meter wide corridor as it passed the Earth. And the reason for that is they wanted to know in a planetary defense, from a planetary defense context, if they had to contact global governments to say where this thing was going to impact, they would want to know where exactly it was going to hit, what country or even what province, or better yet, what city the thing was going to be a threat to. So we all practiced on this thing as it passed by the Earth, and NEOSSat was one of the observers as we tracked it onto the day side. It's pretty impressive what we were able to do. We just saw this thing when it got inside the moon's orbit. The big observatories, they saw it much further out because they had much larger pieces of glass, but we detected it just as it got inside lunar orbit. And much unlike you observers on the ground, satellites get in the way of you even if you were in space taking pictures. So just so you know, these are 2 geosatellites streaking through the imagery while I was actually tracking this asteroid. So don't feel any shame, even when you're in space and you're tracking astronomical objects. Satellites will bother you up there too. So it's pretty much the same everywhere, every place you go. So this here is Comet 46P Wirtanen. This was imagery created by Jason Rowe at University of Bishops. You'll notice that the comet is actually making these little banana-shaped arcs. And the reason for that is that that's the parallax effect of our orbit, where when we orbit the Earth, we see a slightly different perspective on that object several million kilometers away. And that's why it makes those little tiny arclets when it's streaking in through the sky. You might also notice that there's this snowstorm in the background. You see little speckling. That's radiation in Earth orbit. When we run our detector, we get these little hits from high energy protons or cosmic rays actually piercing through the side of our vehicle and hitting the silicon detector that we use to track space objects, and it raises the photoelectron whenever it does it, so we see it on orbit. And periodically, you may notice that it looks like a little snowstorm that flares up every once in a while. That's when NEOSSat flies into what we call the South Atlantic anomaly. It's a radiation hotspot. There it goes. That's a radiation hotspot that sits just east of Brazil. And it's a place where Earth's magnetic field is a little bit weak, and all those particles stream right in, and that's what we see on our detector when we fly through that part of the Earth. So this is one of the design challenges we face, is not just how do you compose nice imagery, how do you do it when you have all of these charged particles, salt and peppering your images on you all the time. This also has the effect of lessening the lifetime of your imager too. We have to do certain maneuvers on orbit to slowly warm up our detector to alleviate the damage that radiation causes out there. But as for doing comets, NEOSSat's good at it, so we're pretty happy with the performance of it. I'm not sure if this is going to play well or not. I'm going to try it, and we'll see if it does here. This is 2I Borisov. It's a comet that is an interstellar
Seen
comet.
at center field is the interstellar comet 2I Borisov, as seen over a period of 60 days by the Canadian NEOSSat orbiting telescope.
Is the audio coming through?
The animation was produced from more than 3,000 separate images acquired during 139 orbits of the spacecraft. The images were aligned and co-edited to compensate for the motion of the object to the star field. NEOSSat is well suited to reach small solar elongation, where ground-based telescopes are affected by twilight and differential refraction.
So it was actually the first time we've ever looked at an interstellar object with NEOSSat. It was actually a pretty fun thing to do, actually. We did get a little bit of tracks on Anamera, the asteroid that went through our solar system, but Borisov was kind of a unique one just because its placement was a little bit better for our observing campaign, actually. I never thought that when we built this vehicle, I'd be looking at objects through it that actually originated from another solar system. That's actually a pretty wild thing. I never thought that we'd actually be doing tracking on objects like that. And the astronomy team at University of Bishops, using the light curve that was generated off of NEOSSat, they were able to infer that the nuclei from that comet's actually rotating about once every 13 days. They did some pretty neat numerical tricks to actually pull out that very weak signal in that, magnitude 17 object when they were tracking it. So we're actually able to pull out some of the dynamics of that object as it flew through our solar system for the short time that it was here to visit us. And using techniques like this, where they basically pull the residuals away from the bulk brightness of that object, that's how we're able to figure out some of the physical characteristics of these objects as they pass through our neighborhood. Unfortunately, I don't have any exoplanet material. I reached out to the astronomer, and unfortunately he wasn't able to get back to me, so I don't have any exoplanet stuff. I do have some NEOWISE imagery from earlier from this summer. Most of the imagery we took is when we were pretty close to the sun. We got down to about a solar elongation of 37 degrees roughly. It was pretty close to the sun. The astronomers took the measurements and contributed them to the Minor Planet Center continuously as NEOSSat was imaging it. We took several thousand images of NEOWISE as it was passing by the Earth, and yeah, it was actually a pretty great experimental campaign for the astronomy team, and was pretty impressive that we're able to pull out a little bit of the tail detail, the the tail from orbit as well. You can see the evolution of it in quite a few of the frames here that we saw from NEOSSat. So I just gave a quick overview of NEOSSat, space situational awareness. So where are we going? And the environment in Earth orbit, it's peppered full of objects. So there's a lot of things for us to look at. Very low Earth orbit, stuff that's very close to Earth's atmosphere is actually a new challenge for us. We're starting to see the appearance of small satellites with small cameras very close to the Earth, much closer than NEOSSat. NEOSSat flies about 800 kilometers altitude. The new ones are like 200 to 300 kilometers or less. And that offers an economical way for industry to basically image the Earth. But at the same time, it's actually a really, really hard problem because the atmosphere is much denser there and it's really hard to track objects when they're that low. So we have new challenges to focus on. We're still going to look at LEO, medium Earth orbit, and of course, geosynchronous orbit. We built NEOSSat and Sapphire. We track the objects right now. The Canadian Forces is now in the middle of the process for developing the Surveillance of Space 2 project. Surveillance of Space 2 is going to be a little different. There's actually going to be a couple of larger ground-based optical telescopes sited in Canada that are going to be tracking geosynchronous orbit. And we're also going to be building a new space segment as well, similar to Sapphire, but with a lot more sensitivity. So we're planning to get this capability in orbit hopefully soon within the next 8 years roughly is when we're planning to get this new capability to orbit. On the R&D side, we're pushing towards building a follow-on to NEOSSat actually, where we do imaging of not just LEO and not just geosynchronous orbit. We have a LEO mission, but we're also going to try to get resolved imagery of satellites that Canada owns in low Earth orbit. So there's some pretty big technical challenges that we're focusing on. Now, there's also a new area that's pertinent to R&D now. It's called XGEO, which means some number times geosynchronous orbit. We usually look out 40,000 kilometers from the Earth. That's the usual environment in the neighborhood that we look at. Cislunar activities are starting to accelerate now. There's a lot more traffic starting to head out towards the moon. So someday, we're going to have to start considering that volume of space that goes out 300,000 kilometers and the giant sphere that that creates in our local neighborhood. This is the new area that we're going to have to surveil. It's not something right now we're doing. It's not something that we have an active SSA program on, but hopefully before my end of my career, I can basically say we can start tracking space objects much further out into space. The furthest object we've ever tracked with NEOSSat was roughly 300,000 kilometers. It was one of the geomagnetic missions that the Europeans launched way out into space. But there's a lot of technical challenges to tracking space objects near and around the moon. And this is where we're going to start looking toward sometime in the next 20 years as more and more activity and commercial interest goes into space. So it's actually a pretty interesting area. I'm very hopeful that we'll be able to start looking towards this sometime later on. And that's my briefing. I was happy to take any questions, and I hope you enjoyed listening in today.
Wow, thanks so much, Lauchie. That was really incredible. I don't see any questions at all, but certainly the floor is open. If people have any questions they'd like to ask Lauchie at this point, please forward them.
If you want, you can turn your mic on if you have the option. I'm not sure if they do or not, but I'm more than happy to answer questions.
Yeah. Chris Young has raised, allow to talk. Okay, Chris, go ahead.
I can't hear you there.
You have to unmute though, Chris. There we go.
Yeah, sorry about that. Just pressed the wrong button. I did enjoy the presentation. Thank you, Lauchie.
Good. I hope you enjoyed it. Good.
Okay. I know I asked you this when we went through the run through to make sure that everything was working through this system. But when you showed that one clip of where one of the satellites just went under the Chinese one that exploded, are any of the satellites currently, or will any of the future ones have an ability to have a collision avoidance system on board so that should something approach them that could obliterate them, that they would be able to avoid that?
So, so the debris from Feng-Yang 1C is still on orbit, most of it. It's still there. When it exploded, it was basically about 850 kilometers roughly altitude. So those are going to cause what we call long-lived debris, and it will be there for hundreds of years. So some of them they re-entered pretty much immediately, but the majority of them will be up there for hundreds of years. So they create a long-term problem. Feng-Yang 1C is one object out of a whole series of objects. Sometimes satellites just explode because the batteries or their pressurant tanks explode on orbit. It happens. So it's not just Feng-Yang 1C being the sole cause of the problem out there. There's a lot of different sources of debris. Now, as for objects that maneuver, yes, right now we do have satellites that do maneuver. As a matter of fact, RADARSAT 1, within 6 months of that event, had to start moving away from some of those space objects from time to time. The Canadian Space Agency triages debris notices, roughly about 1 to 2 a week for the radar satellites that we own. That basically encourage it, or basically forces us to have to do analysis as to whether or not a small maneuver will actually fly us around the object just at the right time as that close approach is occurring or the conjunction is occurring. So, so some satellites do that. Sapphire and NEOSSat don't have propulsion systems on board. One consideration for all new satellites is whether or not we put a small propulsion on there, a small propulsion system to basically avoid these things, because it doesn't take much energy. It's like 1 centimeter per second or less actually to avoid one of these things. It's a tiny amount of propellant. As a matter of fact, in the industry, it's referred to as a mouse fart. That's how much energy is required in order to actually move a satellite out of the way if you're a day or two away from a conjunction. It's a tiny amount of energy. And right now we are looking at equipping the new space surveillance system with the follow-on to Sapphire, and any of the new RADARSAT constellation missions. Debris avoidance was designed in their planning right now, and it's not an automated process per se. That is something we're striving towards right now. It's a big engineering problem because there's so many objects, and you can imagine the millions of computations that have to occur to look at the likelihood of each of these particles passing near each other continuously, and you're doing that for days at a time forecasting. It's a big computational problem, and that's something that's a piece of ongoing research right now.
Thank you. There are a couple more questions. Are country governments generally competing or cooperating in space?
So, so for Canada, in general, we cooperate for everything that we do in space, because there is no national territory out there. It is international territory. Everything you do, you try to do not to interfere with another operator. There's a problem I didn't really speak about in this briefing. I talked about the debris problem, but there's also a radio frequency problem too. Every once in a while, satellites can unintentionally interfere with another satellite from radio frequency map problem, or radio frequency overlap, basically. So you have to coordinate with an international body such as the International Telecommunications Union to basically deconflict who gets what frequencies where. And that's something that is done regularly. For debris avoidance, most countries have agreements with the US government to basically get precise orbit information, just like Canada does, to basically predict and forecast when these objects are going to go by one another. So generally, yes, there is a lot of cooperation in space, but I'm not going to discount there is strategic rivalry, there is competition in space as well, and it's just a matter of nature of the business that we're in defense. There is that natural tendency to want to be better than the other guy, and we as Canadians, we're doing our best to be competitive as just with everyone else in there.
How has COVID-19 affected your research work?
Well, working from home primarily, so I'm tasking a satellite from my home PC, which is a little bit unusual, but anyways, it hasn't actually, It slowed us down for a short while, but it actually, since we're in space, the Canadian Space Agency is always running the vehicle for us anyways. Even despite COVID, we still have personnel that go in on a skeleton crew basis to basically do TT&C operations for the vehicle. And that goes on 24/7. There's always operators keeping the Canadian fleet healthy right now. So it's a COVID certainly put a little bit of a pause to the R&D because we had to all of a sudden start building up our office capabilities in our homes and so forth. But in terms of the operations of the vehicle, it slowed down a little bit at the start, but we're actually back up and running again, just as if we're actually more productive now on a couple of things actually since the COVID pandemic has taken place.
And in our discussions earlier about all the space debris that you have to maneuver through or at least keep track of, question is from Bob Russell, is any activities underway to take out pieces of space debris?
So I mentioned earlier about the mission extension vehicle that's actually captivating a satellite and actually reorienting it and so forth. That's actually one of the piece first technologies on what they call on-orbit servicing for being able to relocate a satellite. That's not something they've done yet, but that's something that they're starting to look toward right now. So you can theoretically grab a satellite, turn on your little propulsion system and move them out into an orbit that's harmless. That's one way that you could reduce risk in the orbital environment. Now, there are studies taking place right now about using lasers to very, very gently nudge satellites. So photons, just like anything else, carries momentum. And if you were to hit a satellite with a bright light, like a laser, you actually put a very, very small pressure on the satellite, and that can change its orbit. So there are studies actually going on by my counterparts in Australia on examining how do you use lasers to basically adjust the orbits and actually try to re-enter some of these things. It's a hard problem because satellites aren't spheres. They do not fit what we call in the physics community a spherical cow problem because they're all odd shapes. They're mechanical devices. But it is a area that is being looked at right now of how do you mitigate debris in orbit right now. It's a very hard problem because there's very limited ways to which we can actually make change on orbit, especially economically. You can launch a satellite, capture something and take it out. That's extremely expensive. Whereas if you could use a laser, maybe that could adjust the orbit over several hundred orbital revolutions to make it eventually decay and re-enter the Earth's atmosphere.
Cool. Paul, Heath, you had your hand raised. Go ahead, Paul.
Yes, I was just wondering with that system where they can go to the satellite and adjust its orbit or like fix its orbit or do maintenance on it. Can that be used to collect debris pieces and amalgamate them into I would assume a heavier object that they could deorbit a lot easier?
That was one theory that was raised some time ago, actually, and I've thought about that myself. Why don't we make a refuse dump just above geosynchronous orbit? Now, the way we classically deorbit satellites out in geosynchronous orbit right now is the operator actually kicks off a little maneuver. Its orbit hops up about 300 kilometers, and they just leave it there. One of the other options is, well, could you actually weld a bunch of satellites together that are finished or expended? They have no more fuel on board, so you can't operate them anymore. Could you do it? Mission extension vehicle doesn't have the robotics capability on board for doing that kind of thing, to my knowledge. Maybe that would be something in the future, but to my knowledge, it's not something that's been tested right now. But there's all kinds of analysts that are wondering about how do we mitigate this problem moving forward. And it's a big one. The stuff in geosynchronous orbit, the lifetime is anywhere between, well, depending on the orbit, it could be around 12,000 years. If you hit the right orbit inclination, it could re-enter in as little as 60 years if you take advantage of some of the strange little orbital perturbations that the moon or even the tides actually provoke on objects in space. But right now, it's a very, very knotty problem, and it's very complex.
Yeah. One of my students during a classroom presentation asked if the vacuum cleaner would be able to work in space, to be able to draw all those, like this was soon after the Chinese blew up their satellite, like to collect all of them with a big vacuum cleaner in space. He was a grade 5 student.
You know what? Good ideas come from the most strangest places, so you never know. Something could appear at some point in the future. So I'm not going to, don't discount him, because he'll probably be the guy that's trying to solve it probably in another 15 years or so.
Okay, another question in from Greg Dill, who says, why are there not more collisions, or do we just not hear about them?
So there have been some. The first that I was aware of was an Ariane rocket that actually incapacitated the satellite that it launched to orbit several years after it launched, and it actually cut the what they call a gravity stabilization boom off of the satellite. So it has happened. Iridium Cosmos is a collision that happened in 2009. You can look up that event. You can look up that event. A Iridium satellite hit a derelict Russian object, and when they hit each other, they caused just as much, if not more, debris than that Chinese anti-satellite event. So it has happened. There was one a few years ago that was a little, it's not really clear if the satellite just simply fragmented or if it actually did hit something else. And there's a lot of the things that we deal with in this business is that we don't have enough sensors watching continuously. And when we do, we look through a little drinking straw in the sky. You only see a tiny little fraction of that volume of space when you're trying to see what's going on out there. It's tough to maintain constant surveillance of these things, because you may actually see another object piercing a vehicle and causing it to fragment in orbit. But it takes a lot of energy and a lot of systems to do that. The simple fact of the matter is we simply may not see it. And like I mentioned earlier, we know that there's probably closer to 500,000 to 1 million small objects from about 10 centimeters down to as small as a centimeter that we know are out there, but we cannot track them. And we do have about twice a year objects just fragment on orbit. And we believe that's either battery or their propulsion systems exploding on orbit. Sometimes overpressurization occurs. We can't say for sure whether or not it might have been a debris fragment that caused that. We can't say for sure because we just simply don't have the measurements.
Okay. Well, I think that's it for Chris. Did you have a question, or did I just forget to lower your hand?
I think you didn't lower my hands.
Okay, good enough.
Thanks.
Thank you. All right. Well, Lauchie, I don't see any more questions, but I see lots of comments here about thanking you for such an excellent presentation to us this afternoon. In fact, I'll have to quote one of our members who said, "So interesting and a fire hose of information." There was a lot of info there for us to digest, and I'm sure some of us might be going through the video again once it's up on our YouTube channel to recapture some of the information that you presented. So thank you so much for all of it this afternoon.
Oh, it's my absolute pleasure. And whenever you see those little mystery dots going across the background sky, Canada's watching them, and in some cases we may be causing them in a few places too. So anyways, it's been a fantastic business to work in, and I really hope you enjoyed the presentation today.
Oh, he said, oh, one more question. What is the crest on the wall?
Crest on the wall on the slide here?
I guess so, yes. In the lower right.
On the lower right, Phantom Echoes is the multinational experiment, and the University of Arizona generated the graphic for this. And what it is actually, it's a little bit abnormal. Satellites don't, when the satellite's in geo-docked, in this particular instance, a geosatellite is normally oriented, I can't really see that there. a geosatellite is normally oriented north-south. Its solar panels are aligned north-south. But when they docked Mission Extension Vehicle 1, they rotated at 90 degrees, so it wouldn't actually be cause physical damage to the other vehicle by the solar rays impacting one another. So that's what the cruciform pattern that you see there. Phantom Echoes is just the name that we picked for the mission. And I'll tell you exactly the root of it. Phantom stands for Phantom Canyon Brewery in Colorado Springs, where we all met to basically devise and come up with the experimental plan and so forth, usually under a few beers. And Echoes refers to the British telecom system that the UK used to when we first started having routine teleconferences with. It was very echoey, so we just called it Phantom Echoes as the Phantom Echoes is how we came up with a name for the multinational panel when we did this experiment.
Okay, interesting. Well, thanks again. On that note, I'm going to put a close and adjourn our meeting for this afternoon. Thank you everyone for attending. Thank you especially to all our panelists and to Lauchie for being our guest panelists today. Again, in a couple of days, if not within the next 24 hours, you should be able to see this presentation of the whole meeting up on our YouTube channel. So please go and view it. So farewell until we see you next time on November the 7th. Take care, everyone, and keep looking up.
Thanks, Al. Take care.